And welcome everyone to the Cassandra Workshop series. Hi David.
Hello. Hello, Cedric. How you doing, man?
I'm very great. We do have a lot of people today. I'm so excited. We are starting a journey for 8 weeks, man. That would be
Yeah,
awesome.
this is 8 weeks that you guys get to hang out with us. Not that we're particularly cool or anything like that, not meant like that, but 8 weeks where we get to take you on a journey from having potentially very little knowledge of what Cassandra is, learning about that, going through data modeling, application coding, admin, benchmarking, all sorts of stuff, right? So this is going to be really exciting, and we're pretty jazzed to get going today.
Yes, and you know what? It won't be only about Cassandra. We will
That's
build
right.
real app, real stuff. So we'll talk a lot about cloud, Kubernetes, API, microservice. That would be fun. Okay, let's get rolling.
All right, let's do it. So first thing, I just want to just set the context here. So for today's event, we've been doing these workshops for some time, and we're used to a certain amount of folks. We've had all of you who've come on here. We just had a wonderful response. Right now, we're at around like 8,000 registrations. So this picture here that you see is approximately about 10,000 people. I realize it's 2,000 more. I'm sure you can kind of figure that in your minds. But just to give some context, the sheer amount of all of you that have come to learn with us for this series is just really awesome. So thank you guys all for coming. And with that, let's get into it. So here's our crew. You may recognize some of us from our emojis or not. I will introduce all of them, but we have a whole team of us here at DataStax, not just Cassandra and I, that are actually supporting these events. So today at the top there, you see I'm David Jones-Gilardi, the guy with the hat. Cedric Levon is my co-host today. Hello again, Cedric.
Yeah, hello.
And,
so let me put us a bit smaller, like that. Okay, moving.
Are we smaller now? Oh, that's
Yeah,
right.
yeah,
We're not
yeah,
going to
yeah.
take up so much
We
of the
were
screen
hiding
anymore.
the text. So funny.
So separate from just myself and Cedric, we're going to be hosting and presenting the material, bringing you through all the fun quizzes and exercises and such today. But we have a whole team of folks underneath. So joining us today, we have Bettina Swinnerton, we have Jack Fryer, our community manager, who, if you have any questions about, the workshop or any of the follow-up stuff, Jack is your guy. Aleksander VOLOCHNEV is another one of our advocates. And then we have all sorts of other folks from DataStax who are going to be in the various chats that are going to be supporting us today to ask your questions. And really, part of the reason for us doing this is for you to be able to interact with us, be able to ask questions. Feel free, right? We'll make comparisons today since we're getting into the beginning of Cassandra. We will make comparisons to relational databases and some differences. So many of us come from that world. If you have questions about relational databases, ask them, right? Ask about how does this compare. Do not feel worried about asking a question or something like that. We're happy to answer. So today, what we're going to cover, this is week 1, right? This is an 8-week series. So we're in week 1. And today, the first thing we're going to do is get you bootstrapped. A lot of you on the chats, we've been watching those chats. A lot of folks are asking questions about, hey, what materials do I need? Are there any prerequisites or anything? We're going to answer all of that here in bootstrapping. This is going to be the session we're going to spend just a little time to get everybody set up. We're going to get a database going. We're going to get all the materials. We're going to get you your resources and kind of explain how all this works. And the cool thing is once we do it today, we won't have to do it in the following weeks. Then we're going to get into the what, why, and when of Apache Cassandra. So I also saw some other questions coming in on Discord and YouTube asking, hey, is this okay for beginners? What happens if I don't know anything about Cassandra? You're totally cool. This is what this is designed for, right? We design these specifically to bring you, if you're not familiar with Apache Cassandra, to then leave with being dangerous with Apache Cassandra, right? So we're going to get into some of the Cassandra fundamentals, explain some of the really cool features. And for those of you who have attended some of our workshops previously and have maybe come to one of these where we do some of the primer Cassandra information, we actually have a little bit more for you today. So in this series, we are able to focus a little bit more in each of the subjects. So today, we're actually going to focus fully on the fundamentals of Cassandra, and we ended up getting, we're able to dig in a little bit more consistency levels and read and write past stuff we weren't able to do before. Then we're going to just very, very briefly touch on data modeling. And the reason why is because to paint a whole picture and to kind of connect some of the dots that we're going to be talking about today, you do need to understand at least a little bit about what's going on in the data modeling piece. However, next week, is when we're going to spend the whole session on nothing but data modeling, right? So we're going to do the deep dive in data modeling next week, but I'm just going to barely touch it today. And then we're going to leave you with essentially the what's next. Here's some resources. There is homework. I will talk about that here in a moment. So then just to kind of give you the skinny, these live sessions will be 2 hours each week. There are 2 sessions. I'll talk about that again in a moment, but 2 sessions for each of the different time zones. Either North America, Latin America is one, the one we're viewing right now, or on Thursdays, we'll have another one for EMEA and APAC to better fit folks' time zones. Each one of those, you just need to attend one per week. You just pick one, and then you'll have about 2 hours worth of homework. And again, I'll get into more detail about that.
Yes, and if you miss one of the live or both the lives, it's not a big deal. Everything is recorded. Everything is available on YouTube. You can go back and watch the live, to get the materials to do the exercise and homeworks. Yep.
Awesome. And another thing I just want to mention as well is there are a ton of you guys, a ton of all of you on the chats. We are going to do our best to keep up. If you are asking a question and you're not getting an answer right away, we are watching, right? So if we don't catch it or something like that, maybe repost it. It's okay. We will definitely get to it. Okay, so I want to just back up just a little bit and talk about the series as a whole. We've seen a lot of questions coming in about the whole series. So here's the plan, right? So right now, again, we're in week 1. And notice that there are 2 parts. So we have part 1, how to build applications with Cassandra. So we're going to start with what we're doing today, the fundamentals of Cassandra, get into data modeling. And then we're going to spend week 3 and 4 really getting into the application development spot. Cedric, this is kind of your fun area. Do you have anything that you want to kind of talk about?
Yes, so really the series is about building stuff. So of course we will start by explaining what is Cassandra, but the reason is really because we want you to build something on top of it, and why Cassandra fit, next generation development. Microservices, API, Kubernetes, all cloud native development. We want to just explain you why it fits well. And of course, along those lines, answering any question you have about Cassandra. And so the 2 weeks, week 3, week 4, really dedicated to building our app. The first will be, implementing the create, read, update, delete operations. And then using either Java, Node.js, Python, or C#. And then we would do the REST API on top of it. Depending if it's Java, we will use Spring Boot or Quarkus. If it's Python, we will use Django. If it's C#, we use the C# stack. And Node.js, we will use Express. So it's all about building stuff together. It will be fun.
And then in part 2, now we're going to start to get more into deploying, monitoring your clusters and your applications, right? So you see there at week 5, some folks earlier before the session started were asking about, is there going to be any administration episodes or anything? Yes. So this is where we're starting to get into more of the admin functions, but it's not all about administration and running your clusters. So you'll notice at week 5, that's where we're going to really kind of focus on how to operate your Cassandra clusters. Once we get to week 6, now we're going to change a little bit and get into performance benchmarking your data models. This is actually really quite important. Funny enough, we did a workshop on this a couple weeks back, and I asked a question in there. These are all anonymous, by the way. You'll see. We'll do some of this today. I asked a question in there about how many people are actually benchmarking their data models, and as I kind of suspected, it wasn't many. And what it really comes down to is, once you are powered by a database like Cassandra and you can do the things that you can do with it, right? Just like any database, honestly, you need to ensure that you're benchmarking your data models, because later on, if your app starts to grow, go viral, and it needs to scale out, you need to ensure your data model is going to go along with you. So we're going to spend some time in week 6 going through that process and what that looks like. Week 7, we're going to look at how to then test your deployments, how to troubleshoot them. And then week 8, I don't mean to kind of throw week 7 under the bus or anything, but I get excited about week 8 because it's just so much fun. If Kubernetes, if you're really getting into the modern orchestration patterns and such, Kubernetes is obviously where it's at right now. And so many months ago, DataStax had released the Cassandra operator for Kubernetes. All free and everything like that, where you can launch and deploy and manage your Cassandra clusters fully on Kubernetes, and it's awesome. So we're going to really cover all the things in this whole series. Yeah, Cedric, do you have anything you want
Oh,
to add
yeah,
back there?
and the app we have built together, we will deploy that as well on Kubernetes, of course, close to Cassandra.
Yeah. All right, so that gives you the feeling for the whole series. All right, let's get into it. Ooh, my button's in the wrong place. There we go. All right, so how does it work? So again, I saw a lot of questions about this today. So I promise you, we're going to answer all your questions here. And if we don't, obviously ask them. But I hope this is going to answer a lot of what you are all curious about. So how does it work? First thing is each week we will have 2 sessions, one for North America, Latin America, one for EMEA, APAC. Those are the same exact sessions. There's no difference there other than maybe the people presenting. The material's the same and everything. It's really just to fit into better time zones for people in different parts of the world, right? So you attend one of the 2-hour sessions each week. Now, what that's going to look like is we're going to have courses for you to look at. As I mentioned before, the Discord, we might as well go ahead and pop the Discord. Let me do this real quick. Discord. Now, a lot of you are, oops, that was the YouTube link. My bad. Sorry. Sorry, let me grab the Discord. Here, I've got this like always here. Here, let's try that again. I'm going to pop the Discord link here. There we go. Wonderful. If you are on the YouTube chat, that's perfectly fine. However, the YouTube chat's a little limited, right? We can do a lot more in Discord. So we really prefer, if you want to interact with the team, that you go to Discord. By the way, I didn't turn off my Discord notifications, I noticed today. So please be nice if you DM me, because it will show up right there.
Can I try? Can I try?
Yeah, you can. Go ahead. Yeah.
All right.
While Cedric is going to troll me live. So separate from the Discord and YouTube, again, that's where we're going to have interaction with chat. Then we're going to do quizzes and surveys with Menti.com. Now, I haven't turned it on yet. I saw a couple of you were saying, hey, the Menti's not working. It's because I have not actually started it. So we'll get there in a second. And then for our runtime. So, oh, there it is. Yeah. Hey, Cedric.
Oh, so it's working.
It is definitely working. Yeah. Yeah. I know.
Funny.
I just told everybody, right? Isn't it like this thing you're not supposed to do?
Oh, jeez.
And then for the runtime, so there you go. See, I knew when I said something it was going to happen. Yeah, we can have fun with
now
that.
you
Just
need to
be
shut
nice.
down Discord. Oh boy.
But then for the runtime for the database today. So a lot of you were asking about prerequisites. Do you need to download anything? Whatever. I'm going to get to the GitHub repo in a moment. But for the first 4 weeks, we are going to use Astra. I'm going to talk about more what Astra is in a moment. Hi there. I'm going to talk about is it Shailesh? Shailesh, hi Shailesh. I will accept that friend request when I have a moment. We will be using Apache.
I will go at that. Yeah, let me take over here.
I'm gonna have to stop looking up there so I stop getting distracted and laughing. We are going to be using Astra, which is the DataStax Apache Cassandra in the cloud managed database, right? It's like a click button Cassandra database that you can just launch and go. It's made and built for developers. We're going to talk more about that. We're going to use that. We're going to use that for the first 4 weeks. So we're going to do that in the beginning. Then all of the materials, all of the slides, all of the exercises, everything you need is in the GitHub repository, right? So we'll be sharing that out with you as you guys need that.
Yes, the GitHub repo is in the description below the video on YouTube. You do have all the links, Astra, materials,
thank you, Cedric, for
Discord.
reminding me that it was in the show notes
just
for the
below
YouTube
us.
video.
Yeah, should go and click.
Yeah. So we'll drop the links as well. Hi, Neo. Hi there. I will also accept that friend request when it comes. So all of the materials that you need are in the YouTube show notes, but we will also provide them as we go. And then finally, the last one there with the coding, starting in week 3, we're going to use Gitpod. If you're not familiar with Gitpod, I'm sure Cedric has something he wants to talk about that. Or I should say Cedric, he's over here.
I'm here.
But Gitpod is a really awesome tool that allows us to be able to, you can just go to a GitHub repo. Once you've hooked it up, then you can just launch essentially a Theia IDE right in the cloud, right off that repo. And we're going to be using that in the code examples. So Cedric, anything else you want to say about that one?
Yeah, so it's like Eclipse or Visual Code, in the cloud. Just click and boom, it's working. Everything already installed, Java, Python, Node. It's just great for, as like that, you don't have to install anything to do the exercise live, because the 2-hour session is not only us talking, you would have to do also exercise during this 2-hour slot.
Yes. Now, by the way, I'm seeing a question that just came in the YouTube. Discord is asking for creating a server. Let me make sure that link, when you go to the link, it should.
Yeah, it should be bit.ly/Cassandra-workshops.
Let's see what's going on.
Cassandra-workshop.
Yeah,
Yeah,
do you have a better link, Cedric? You want to give a different link? You want to drop the bit.ly? But this link should bringing you right to the Fellowship of the Cassandra Rings server. You shouldn't have to create a new server or anything like that. Yeah, that's right.
Yep. All right. So
hopefully.
Yeah, I'm pretty sure the folks with there will help you finding the proper link. Yeah, but
I did see some questions about the GitHub link. We are going to drop that here soon.
Yeah, bit.ly/Cassandra-workshop is written on the slide. And again, slides are also in the GitHub repo.
Yes, that's right. Right. All the links that we have are embedded in the slides, and that's also in the repo. Okay, so the next part then, number 2, is homework. So here's how we've set this up. We'll do 1 2-hour live session that we're doing now per week. And then each week, we're going to give you about 2 hours worth of homework, right? Now, the homework is especially important for those of you who want to go on to take your Cassandra certification exams. The homework is specifically, I mean, it's built off the very courses and the quizzes and everything that feed what the actual exam questions are, right? So if you are planning, we really encourage this. You know, and matter of fact, as part of what we're doing in this series, you will eventually get a voucher to get yourself, a free certifications exam, right? That's usually like $375, I think they cost. So we're giving that to you as part of coming to this and spending time with us and everything. And that will be something that we're going to do later on in the series. But once we do that, if you go to take those exams, you're going to need the homework. You're absolutely going to need it. Now, the courses, the way they're designed, you can sit and watch the videos and take the quizzes, and essentially you'll have all the information you need to do the exams. And that'll take you around 2 hours, right? Now, there are exercises, though, that are also in those courses. If you really want to get your hands dirty and really want to get into it and learn, do them, right? They're worth it. They'll usually have you download a VM, you go in, and you really start messing with Cassandra clusters, and like I said, getting in there really deep. Now, that's going to take a lot longer than 2 hours, but that's totally up to you. It's not required. Right? We really suggest that you take a look at it, but it's not required. So again, it's going to be about 2 hours for one of these and then 2 hours for your homework. Okay, so last couple things before we start, getting our databases going.
Mm-hmm.
So you'll find out the top left there, you see that community.datastacks.com. So there are a lot of you here. And there are a lot of questions. And some of the questions that we get sometimes are kind of longer form. It may take us a moment to respond, not just from a standpoint of trying to keep up with during the live session, but because they need like a more comprehensive answer or something. This is exactly what community.datastacks.com is for. It's like Stack Overflow for Cassandra. There are a ton of Cassandra experts, both internal to DataStax and external users, power users of Cassandra, who've been doing this stuff for years that are there out in community answering those questions. So what you might notice is that sometimes we might actually answer your question in the chat with a link from community.
Mm-hmm.
What that means is we've actually gone and posted that question up in community in a special group we've created for the series to go ahead and answer it in that kind of longer format. So if you see something like that, we're not just like dismissing you or something and saying, go to this link. We're setting it up so we can have a longer conversation and we can kind of follow up after the event. So we really encourage everybody, go take a look at community and ask your longer form questions there. Or if you ask them in the chats, we may respond there as well.
Yes, I do have a question here about do we get any certification or validation that they took the 8-week courses that we are doing now? We are thinking about, of course, rewarding you to be with us during the full. I don't know if it would be a certification or a swag box or the badges the form will take, but yeah, of course, we will reward you to take the full 8 weeks. But after the 8 weeks, you would have all the knowledge to pass both certification, both developer and admin certification.
Right. Okay, so then the training that I was talking about, the courses, that's at academy.datastacks.com. By the way, don't think that we're expecting you to memorize all these links that these URLs we're sending to you. We're going to provide them not only in the materials, they're in the GitHub repo, they're in the show notes, and you're going to get an email follow-up. Like you're going to get the links.
We will spam you, yeah.
Yeah, you don't have to memorize all those, right? So academy.datastacks.com, even separate from the coursework that we're going to give you as homework, there are a ton of other courses and content out there. It's all free, by the way. DataStax provides this stuff all free. So if you really want to go on and get your Cassandra on and like learn even deeper on all sorts of things, it's a great place to go. Then finally, the validation form. So this is like the social contract that we are kind of building right now with all of you and us. So every week, we're going to give you a validation form. All this is a couple questions, maybe 3, I think this week, or 3 or 4,
yes,
to answer that show us that you have gone through the materials and the homework and such. If you do this, and if you answer them all correctly, right, then at the end of the series, if you get them all right throughout the whole series and you submit those, then we're going to pick a random 10 out of all the winners, and you're going to get some cool swag. Right. So this is kind of a nice way to let us know that you're able to get through the materials and such, and that you're understanding things. And at the same time, there's a little incentive in there for you. So Cedric, anything else before I move on with all this?
No, don't worry about the question. Those are not tricky at all. It just validates that, you know, you took the exercise, what was, you know, in the textbook of the exercise, or very, you know, not difficult questions.
Okay. All right. And by the way, I'm just watching the chats. I am seeing...
Can you? There is so many messages.
Yeah, there are a lot of messages coming through right now.
Yeah, I have a hard time reading
all over them. Yeah, I do see a lot of questions regarding the materials and stuff. So as we go through, hopefully this will be clear. Like I said, all the materials and everything you need will be provided to you. Okay, and then the last thing. So attend one of the sessions, do the 2 hours of homework, and then relax and chill out. Right? You just learned a bunch of cool stuff for the week. Cool. Time to relax.
All right.
We're going to move on to our first exercise. It's not really so much of an exercise. It is more of just kind of getting set up with the Bootstrap. But what we're going to do here is we're going to first go to GitHub repo. We're going to clone the repo.
Again, I'm in
right?
front.
Let's go ahead and do that. So the first thing I want you to do, and I will drop this link for you all. And again, it is in the YouTube show notes, but here is the GitHub repo. Here is the GitHub Lico. Something weird came out of my mouth. GitHub repo, not GitHub Lico. Yeah. And oops.
Yes. So as usual, everybody's on GitHub. You should, either download all the repo as a zip or clone the repo. Each week we will add new stuff in there. We are building we are making the content better and better week after weeks. So it will evolve over time. So week 2, 3 to 8, we still amend the content during the weeks. So we would have to pull the new stuff every week.
That's right. Yeah. So it is. I think it is a better choice this time around to go ahead and do a clone. So what we'll do, and I'm going to actually do this with you real fast. So all right. Let's see. Where am I? I'm in my base directory. Okay. So here's what we're going to do. I'm going to make a directory. Now, however you want to do this is totally up to you. If you're not familiar with GitHub, that's okay. You can, if you click this clone here, as Cedric just mentioned, you can either download the zip or you can clone the repo. If you're not familiar with GitHub and you've not done it before and you don't have like Git installed locally, just download the zip, right? You'll have all the materials that you need right there in the zip. If you are familiar with GitHub and you've used it before and you are using the Git executable, then you can just copy the repo reference here. And now in my case, I'm just making a directory that I'm going to put this in, but I'm going to say git clone. I should probably make this bigger so people can actually read it.
Yeah. It's
sorry.
Yeah, you can hardly read.
I know that by this time. All right, hopefully that's easier to read.
Yeah, git clone and the URL, yeah.
I'm just going to put the link to the GitHub repository. Again, I got that from clicking on clone here. And if you just click this little button there, it'll do it. And then going git clone, and here is the name of the repository. And that's it. That is literally your prerequisite. And funny enough, the only thing we're really doing that is pulling the notebooks, right? Now, you'll notice that once this pulls down here, okay, go to the directory, you'll see that we have all sorts of weeks, right? So for today, we're going to go into week 1. I'm just doing this now. And I'm using tab completion, by the way. Obviously, there's no way I could type nearly that fast. So if you happen to have a machine that does have tab completion, it'll be your friend. And you'll notice there's a set of folders in here. The README is going to be the README we're going to see in a moment in the GitHub repo. Images, don't even worry about it. It's just the images we work with. Notebooks, we will use some of the notebooks today. And then slides. Slides, the whole deck, everything that we're doing here is in PDF format in the slides directory. By the way, this is all available on GitHub. So if you are cloning, like I said, just go ahead and do a git clone of this repository here. Again, you can click on that button and copy it. Now, here's what I would like you to do. If you could please give me a thumbs up here if you've done that. We'd like to get an idea. We just want to make sure that folks are at that stage and you have the repository.
Yes, and also question on the chat. So you don't have to install anything. You know, during the 8 weeks, you can do all the exercise using only your browser. We will provide everything. Yes. You know, IDE, runtime to execute Docker containers, everything. You don't have to install anything. Now, to do the homework and, you know, get the Cassandra certification at some points, you know, you cannot be a Cassandra expert without installing Cassandra at some points, but not during the workshop, not during the live at all.
That's right. And I am seeing some questions come in. Do you have to do this with this live? No, you don't. No. You can wait and do it on at your own pace during, you know, the recorded session, which will be available right after the video. You can just watch us during the live session if you like. Totally up to you. So no, you don't have to do it live. And and if you're not able to clone, here, let me go back to the correct screen.
Yeah, you can download as a zip.
Yeah. So if you're not able to clone, if you haven't used Git before, if you go to the repository again here, I'll post it another time right there in both chats. Here, I'm dropping them in both. There you go. So if you go to that link, and again, you should see a page like this. Go to the clone button. Oh, minimum system requirements. Yeah, hi Streak, I saw that. There are no minimum system requirements. Everything we're going to do today is done online in the cloud for that very reason. Yep. All you need is a browser, not IE. Any other browser is fine, just not IE.
Oh, wow.
Yeah, but no, everything we're going to do is on cloud-based machines and all that, so you don't need any minimum requirements for today. Okay, and then to finish this off again, if you hit the clone button, you'll see either the zip option if you have not used Git before, but if you have, just copy the repo URL there, and then the command will be git clone. I said git clone, and the name of that repo.
Yep.
Yeah. Oh, that was funny. Yeah.
Yes, we will use Astra. Yeah, that's correct.
That's funny. Yeah, we're gonna use Astra today. Okay, so with that, I saw a ton of thumbs up. It looks like we have a lot of folks that are good with the GitHub repo. So what I'm gonna do next is I'm just gonna click on week 1. So notice what I did there. I went to week 1. This is where we're gonna work out of today, right? So the way we set these up is you'll see that when you start, you're going to have, the link to the slide deck, and then we have anchors set up. So I can just click on that and go right to the section. We just did this, right? We just did this section here.
Yeah, and that's a point I want to make. So each week will work the same. We take a little more time as usual because it's the first one, but you will find all the materials and all the steps you need to go through in a single README like that. So if you're already familiar with the concept we are presenting, you can go on your own and start moving through the exercise on your own as well. All in there.
Yes, that's right. That's absolutely right. Okay. All right. So for the next part, then what we're going to do is, if you're using Ubuntu, you should be totally fine. You don't have any IE in there. Exactly. Yeah. See, now I'm able to watch all the people's messages come through. Okay. So for the next part, once you have either downloaded zip or you've cloned the repo, you're good to go from that standpoint. Next piece is we're going to create our Astra instance, right? So again, if you go to the GitHub repo, if you click on that, create your Astra instance. Now I'm going to do this along with you. For those of you who are following along, you're doing it right now, you should do this right now as well. So you'll notice here, I want to go to astra.datastacks.com. So I'm going to go ahead and click on that.
Yeah.
Oh, by the way, the Markdown language does not allow us easily to put in target blank. So you will need to control click or middle click in order to go to another tab. Slight annoyance. But.
Yep.
Now at this point, if you haven't registered before for Astra, again, we're going to use a free tier. There is no paywall here, nothing like that. This is, we're going to create the database.
Yeah.
If you haven't registered before, just follow the instructions that are here on the page. even though I'm going to walk through it myself. I've already registered, so I'm just not going to go through that step. But it should just take a moment to get your registration going. And we're going to give you guys a moment to get that up and going.
Yes, and all the fields you need to provide, please provide the proper key space. It's killer video, KILLRVIDEO. Why? Because in the exercise later on, we expect that you use this key space name. You can, of course, you can provide the one you like, but then you will have to change the textbooks in the exercise. So.
I'm just answering a question.
Sure.
The question I'm actually answering is somebody asking, hey, wouldn't this be easier to do in Docker? We've actually done a ton of these workshops using Docker before. Here's what we run into and why we do stuff in cloud resources. A lot of times, folks, personal laptops, whatever machines they're working on, just don't have the power. Once you start running like a base Cassandra workload isn't that bad. But once you start kind of ramping things up, especially when we get into the Kubernetes one later, you need a pretty powerful laptop, lots of RAM. Not everybody has that. So we found it was a lot easier to just start doing this thing through cloud resources. That way you don't have to, you could literally just come in with a browser and you're good to go. So that's what that's about.
Yeah, but not only that, I would add that when you do Docker with Cassandra, the image is about 600 megabytes. And if everybody starts to Docker pull the image right now, it will take a while, to have everything downloaded and ready to go on your laptop if your network is not that good. And probably with YouTube already, we are sucking most of your bandwidth anyway.
Yeah. Oh, can you use your Academy credentials to log into Astra? No, it's not like a single sign-on or anything like that. It is a different registration for now. So you will have to use something else. I did see some messages coming through. It looks like, I think with the sheer number of folks we have hitting the sign up page, it might be timing out a little bit. Let's just give it just a moment. Really what I'm looking for is for you to register and get to this page here where you're waiting to create a new database. I'll make sure that we're reaching out to the Astra team and they are good from that standpoint.
Yeah, I can write to them.
Are you talking to them, Cedric?
Yeah,
wonderful.
yeah,
Thank you.
Yeah.
Okay, yeah, we'll give it just a moment to kind of catch up. So again, if you're having trouble with that, try to retry as much as you can. Let's see. Okay, I'm still seeing. Oh, the Astra URL. It is right here in the repo, but I will drop it.
Yeah, you can click on the repo or go to astra.datastax.com.
Thank you. Yep, I just saw Tishay, or Tish AY maybe, I don't know, who posted it. Thank you for doing that. Yes, the database name and key space we have not gotten to yet. That is here in the instructions. So once you follow this down, you will find the step 1B. Once you get here, we're going to give you exactly what those values need to be. So for this session, we really do ask that you use the values that we have here. The reason why is because the notebooks, the code later on, everything, they're going to be based off of these particular values.
Yes.
When you're playing around with Astra on your own and you're playing with your own databases, this could be whatever you want. But for today, we do ask you, please use the values that we have here. So you'll see the database name, killer video cluster, killer video, so on and so forth. And let me go ahead and I will start this on mine since I'm already here. So hopefully you're going to see a page like this. I do recognize that some of you are getting the temporary unavailable piece. Yep. Yeah, so we'll get that fixed up. I'm going to move on for now, and then we'll make sure to follow up with you as far as getting those running. So for those who are at this page, make sure you select the free tier, okay? This is the same information that is also here in the instructions. Oh, Sheen, hi, I see that. Yeah, your friend doesn't have to register to show up. You could just have them show up. Jack, if you could post me the link to the Eventbrite, and then I'll get that over to O'Shea. Okay, so what I'm going to do is, first thing, again, pick the free tier. That is very important here. We're not trying to charge you for anything. That is free forever, by the way. Now, I'm here in the East Coast of the US, so I'm going to pick US East. But if you happen to be somewhere else that's closer to Europe, please pick that. Now, here's where this database, key space name, and such come into play. So you notice I say the database name is Killer Video Cluster. I'm going to put that here. Then the key space name is Killer Video.
Yep.
Put that here. Username is KV user. Notice it's camel case, capital V, capital K, capital V, capital U. And then the password. Again, these values are all here in the GitHub repo. Once you've done that and you're set up here, yeah, Rochelle, we are seeing, it looks like we're getting, the sign up service is getting a little bit overloaded, and we have reached out to the team for that. So just sit tight and we'll get you going from that standpoint. All right, so once you're here, and hopefully, given what I'm seeing, this works okay. And it says launch database. This is going to launch your database. Now, this might take a couple minutes. Yeah, thanks, Rochelle. Okay, let's see. Okay, somebody was just asking me for the link for their friend to register. I'm going to drop that in the Discord there. Thank you, Jack. Loaded, good. Okay, so some of them are coming through. Yeah, you know, I see a neat question from Cryptos Chain, wondering why it's called a database, right? I see it's a cluster name. So yeah, so even though Cassandra, Apache Cassandra is a cluster distributed system, it is still a database, right? And so when the cluster part of it is really more like an implementation detail. We're actually going to talk about that here in a moment. So think about this as your database. Even for all of those nodes in that clustered kind of like a way it exists, you still have a single access point that acts like a database, right? So it's still a database. It's just a cluster distributed database. So I'm going to talk more about that here in a moment. All right, so we're going to let this launch. Yeah, I'm going to move on, everyone. And Cedric is already talking to the team to make sure that we can get that going. I think with so many of us on here, that was just a lot all at once. We kind of wondered, right, if that was going to happen with a lot of people to have all load up at once. So we'll just give it some time. Just kind of keep trickling them.
Yeah, we will go into a few slides. So yeah, the service will have time to recover a bit, or absorb this load.
Yes. All righty. All right. So great. So then for Astra, what is Astra? So the first thing I mentioned is Cassandra as a service, right? So it's DataStax is essentially a longtime expert in Cassandra. We're the main company behind Apache Cassandra, all the drivers, everything. We've been running Cassandra clusters and databases for years. And so this is a service that is a fully managed Cassandra in the cloud service. You essentially fill out the details that you saw me fill out, press launch, that's it. You have a fully supported Cassandra cluster that is now running for you. And it was really built for developers, right? So you'll find that a lot of the tools that are available are there to make it very quick to be able to go spin up a database, get going, and then have the tools that you need to securely connect to that database. So this really kind of eliminates the need for you to install it yourself, manage it yourself, all that kind of deal. There are REST APIs and GraphQL APIs right out of the box for those who want to use something like that. It is in fact powered by the Kubernetes operator for Cassandra. So when we get to that session later on in week 8, you will find it's, we eat our own dog food with this stuff. So the very same operator that we're using for Astra is what we're going to be using for Kubernetes. And then from the lock-in piece, right now it is available on AWS or GCP. And there's no lock-in to any particular cloud provider. There will be more coming. And that free tier that we're using is a 10 gigabyte tier that will be available indefinitely with no credit card or no paywall, anything like that. If you haven't used Cassandra before, you'll find that the language should look very familiar. For those of you coming from a relational background or familiar with SQL, CQL, the Cassandra query language, looks and feels just like it, right? So it should be very familiar. That is a language that we use to do things. One of the dev tools that is paired with Astra is Studio, DataStax Studio. It is automatically configured and hooked up to your Astra instance, so you don't have to do anything more there. Once we get these up and running, we'll start working with the Studio notebooks. And then lastly, pretty much all the major drivers, all the major languages are supported, right? And all the drivers, regardless if you were using C# or Java or Node or whatever, they're all going to use the same, they usually kind of keep the same parity, and they all work with Astra just fine. What's also cool about those same drivers is that you can not only use them for Astra, you can use them for open source Apache Cassandra, you can also use them for DataStax Enterprise. So if you had a single application that in one case, maybe you're starting off and you're doing some test, testing environment kind of stuff, and you just want to spin up something in Astra in the free tier, you can do that. Then if you want to go ahead and hook up to your own Cassandra database, it's one line of code change with the same exact driver. right? It's made like that to be as absolutely seamless as possible, so you don't have to mess around with changing a bunch of code and everything when you're changing the versions. Okay, so let's see. How are we doing, Cedric, as far as I still see messages. Folks,
yeah, so I think it's the authentication service which is struggling at the moment. I don't think this is provisioning, a bunch of multi-thousand VM. But yeah, we are working on it.
Okay. So what I'm going to do then is I'm just going to go ahead and continue to let them work that piece. Yeah. No, I don't think there's a Golang driver. Cedric, do you know that one off the top of your head? I don't believe there is a Go driver.
A Go driver? So there's something called GoSQL, which is it's existing. It's not maintained by DataStax, but yeah, there is a Go driver out there. It's called GoSQL.
So it's just not maintained by us.
Yeah.
Okay. So if you've gotten to this screen, that is wonderful. If you've gotten to a point where the database has gotten up, but for now, it looks like the authentication service is having a little trouble, so we're going to let them catch up. Why don't we get into the material? And the cool thing about this is that even if we have to spin up the Astra databases a little bit later, it takes us a little bit. You can always do that after the fact, and after the session today, after the live session. Okay. So this next section is really getting into the what, why, and when of Apache Cassandra, right? Let's talk about what Cassandra actually is. So first off, Cassandra is a NoSQL distributed database. So notice the NoSQL, right? It's not relational. This came as part of the NoSQL revolution, and it's a distributed database. That means that it is built of more than just a single instance, right? So if I was talking like MySQL or Oracle, yes, I may have like a leader-follower kind of setup where I can have read replicas and such. But they are not built to be distributed at their core. Cassandra is in fact built to be distributed at its core. So now Cassandra is built of what we call nodes. Each installation of Cassandra is a node. Each one of those nodes has a set of capabilities. Now, something I just want to point out here is you'll notice that I kind of tongue-in-cheek for the throughput, I put lots of transactions a second a core. What I really mean by that is, capacity, throughput, those things can be completely based on the hardware that you have for a particular node, the version of Cassandra you're using, all sorts of things. Just know the throughput, that is many thousands of transactions a second per core, right? I think the minimum would be about 3, maybe up to like 12,000, depending on how your node is sized and the version that you're using, right? That's why I put lots in there. Capacity about, say, 2 to 4 terabytes per node. Now, what's interesting about this is, again, I said it's a distributed database. That means that I have multiple nodes that will form my database. So somebody was asking that database question earlier, right? Even though it's a cluster, why do you keep saying database? Because right here, this here is forming my database. All those nodes actually form a single database, right? It's just an implementation detail that they happen to be distributed nodes. So these nodes communicate through a protocol called GOSSIP. Little later on, I'm going to start talking about things like token and token ranges and what happens if a node goes down, and there's all sorts of other ways that these nodes communicate. It's a peer-to-peer leaderless system. So what that means is that from a leaderless standpoint, any node can do what any other node does, right? There is no special node. Any operation that a node performs, another node can perform. And you're going to see how this becomes really important to the power of Cassandra. And GOSSIP is just one of the protocols that's used to communicate a lot of that information, things like token ranges and certain state. And this is being done automatically, right? You don't have to manually do this or anything. And then finally, nodes are logically connected through what's called the data center, or the ring, right? So here, this would be an example where I have a ring of nodes that form my Cassandra database. Okay, so one of the really cool features in my mind of Cassandra is its ability to scale linearly. So what does that mean? That means, let's say if I want to double my capacity or if I want to double my throughput, I double my nodes. And this scale is essentially indefinite, right? The funny thing, the chart that's here that only shows up to like 32 nodes, I know of Cassandra clusters out there that are thousands of nodes, and this still holds true, right? So if you take a look at on the x-axis there at say 4 nodes, by the way, don't look at these numbers going, oh, 4 nodes equals 50,000 operations a second. That's not, again, it depends on how things are sized, depends on the version, all sorts of things. What I really want you to pay attention to is that at 4 nodes, in this case, I have 50,000 operations a second, but 8 is just about 100,000. You see 16 is just about a doubling. 32, so on and so forth. And this holds out as you increase the size of your cluster. So you can essentially indefinitely scale up your database as you need to. And this is done by horizontal scaling. So many of us who have worked with databases and systems in the past, we're used to vertically scaling, right? The joke we had back when I used to work on Oracle is, you can scale up until you run out of money, right? That's the joke, right? You can add faster, faster, more CPU, more RAM, faster disk, whatever. But at some point, you can only go so far. Cassandra solves this by allowing you to scale out horizontally on lower commodity hardware, so you can just add more nodes into the system. Now, again, the data that you see here, like saying 3 nodes, 100,000 transactions a second, don't get caught up on that part of it. This is an illustration. So what I want you to really take away from this is that 3 nodes at 100, if I had 100,000 transactions a second, if I wanted to double that throughput to 200,000, I would add another 3 nodes for 6, so on and so forth. Cedric, do you have anything else you want to add into this as I'm
maybe a couple of famous famous brand, famous company using Cassandra, like Apple made some public statement that they have about 175,000 nodes of Cassandra.
Yeah,
that's
that's a crazy one. Yeah.
And some cluster with 12 petabytes online. Cassandra is a real-time database, so you can have petabytes of data available online. So with that much volume, we will have some trade-off. But it's
exactly. And by the way, I just saw a couple questions come in. One was, does each node represent a different machine or whatever? It can, absolutely. It could be different VMs, right? It really depends on the hardware and the setup. But yes, each one of those nodes is an instance of Cassandra, whether that's a physical machine instance or if it's something like you have a bigger single machine that has like multiple VMs or multiple instances running. So it's just an instance of Cassandra. Another question I saw was, is it nodes per data center or nodes per cluster? So in Cassandra, we're going to get into this in a moment. In Cassandra, you have the concept of data centers. You can have more than one data center. So let's say I had 2 data centers. Then all of those nodes would form my cluster. Right, so the cluster is that single database entity, and then I can have multiple data centers there. So honestly, it could be either. It just depends on your setup. Okay, so one of the questions we get all of the time is, well, you've got this distributed database, and I put data in the system, but how does it know where to go? How does it, is it just sending the data to all the nodes, or what's happening there? Here's what happens. This is a very simplistic example. But if you take a look at the table on the right-hand side, you'll see that I have country, city, and population. Now we'll get into what partition key means later. Just know that in Cassandra that the base unit of access is a partition. So again, we'll get there later. But that's how the data is going to be split up and sent around my database. So as I have some data coming in to the system, that data is going to automatically get distributed around my database. This is not something I have to do manually. And if you notice that there are some cases where in that partition key that you saw, like USA there at the top, right? Well, that's actually the same partition for that data. So that's going to go to the same place, right? But the data is going to be naturally spread around my database. And you're going to see in a moment where this distributed nature comes in, where it, where it really kind of shines. Okay, nice, Cedric, with replication here.
Yeah, wait again, click again.
Oh, there we go. Okay, Cedric added something to our slide.
Yeah. So I just replicated myself,
Yeah, we replicated Cedric. Just bump Cedric here.
So your data is replicated as well.
So one of the other really cool core tenets of Cassandra, its ability to replicate, right? And this replication is automatic. So now I've got this ring with these nodes in it that form my database. And we just talked about how data gets distributed around that ring, but how does this actually work, right? Here's what happens. So notice the numbers that you see here in this ring. We're going from 0 to 100. Now, by the way, these values, we just use 0 to 100 to make the illustration easy to explain. The real token ranges are an astronomically large number. You're not going to run out of those. We just, again, it would be absurd for me to actually put the real values up there because you'd see these long numbers, that take up the whole page. So point being, you're not going to run out of these tokens. We're just using 0 to 100 for this example. Here's what I want you to understand, though. If you take a look at each of these nodes, you're going to see they have a number. What I'm saying is each of these nodes owns a range of tokens. So if I go from, I got 0 to 17, 18 to 33, 33 to 50, to 49, so on and so forth. They're going to each own a range. So what happens is that when some data comes in, let's say I have data going to partition token 59. Now, by the way, if you're asking, how do I know where did partition token 59 come from? Don't worry, we'll get there. Just understand that for now, some data is being written. I have a partition token value of 59. How does the system know where to put it? Well, what happens is that any node can handle the request. Remember, I mentioned this is a leaderless system. So any node gets that. It just happens to be the one on the top left. And that when it handles the request at that time, that's what we call the coordinator node. It just means for that moment, for that request, it is now taking on the operation to manage this particular write. So the coordinator says, okay, this is for partition token 59. Where does that need to go? Well, guess what? Remember, down here, you see this purple guy from like 51 to 67. Well, 59 fits in that range. The coordinator node knows that because, again, they communicate. These nodes are communicating all the time, so they know what ranges each one has, and the coordinator sends that down to the node that has that particular range. Now, this is what we call a replication factor of 1. I only replicated to one node. What happens in a replication factor of 2? Check out what just happened there. I add a ring, and I shift it. Now, if we take that 67 there as an example, that purple color, notice now I have 2 of the rings that have that purple color. I have 2 nodes that cover that range. So what happens when some request to write data comes in? Well, here we go. We have our partition token 59. Now this time it just happens to be that node up there in the top right, that one that's labeled 17, that now becomes my coordinator because it's handling the request. It knows that, okay, I've got a replication factor of 2. 2 of those nodes have this data. I'm now going to forward that data on to 2 nodes. Now 2 of the nodes have the data. What happens to replication factor 3? You guessed it. I add a ring, I shift it, and now 3 nodes own that range. Notice the purple color again in the rings. You'll see 3 nodes own that range. Again, if I have some data comes in, coordinator goes, I have 3 nodes that own that range. I'm going to forward that on to those 3 nodes, and the data goes into 3 places. So now there's something really cool to point out here. There's some really neat benefits you get from this. Some of you might be thinking, do I have 3 copies of my data? Yes, you do. So from the total system, do you have more space that you need to use in disk? Yes, you do. But disk is cheap, honestly, compared to all the other commodities, right? But here's the benefit that you get. Right now, I have 3 nodes that at any time can facilitate a request for that data. So I automatically have a natural load balancing that can happen. And the drivers actually do a lot of this for you. So there's a performance benefit there for 1. But for 2, what happens if a node goes down? How many of you have been working with AWS where an instance gets reset for a security update, or you have on-prem stuff and a hard drive fails? Whatever, things are going to fail, period. They always do. Cassandra was purpose-built to be able to handle these types of cases. So in a case where if I had a node go down just like this and I had a request to write some data, well, guess what? I can still write my data to 2 of those nodes, but I'm still not lost yet because at that coordinator, the one that acts like my coordinator, it'll store what's called a hint. And it'll wait for that node to come back up. And when that node comes back up, it'll replay that data on that node to ensure that all of them are in sync, right? So this is some of the self-healing mechanism that is already baked in to Cassandra as part of just how it works. And there are even some configurations that you could lose 2 of those nodes and you could still be available up, able to read and write data. And then when those nodes came back on, they'll automatically replay.
Yes.
Before I move on, Cedric, you got anything else you want to add
Oh
here?
Man, the chat is on fire. I do have
Is it
so
really?
many
Should I
questions,
stop and look at
so
the-
I will
Should I
try
stop and
to
look what's
make
going
some
on?
questions. So first, the coordinator node is per request. It's not an hidden
Yes.
master node. When we call
That's
about
right.
coordinator, it's per request. The client come and can ask any of the node to take the request. So this node becomes the coordinator node for my request. And how does a client will pick one of the node? It can pick any of it. The data is evenly distributed. It can pick any of the node, and this node will become the coordinator node. Then the coordinator node will, send the data to the proper replica. He is sending, the data to multiple replica in parallel, but the replication is async, and we will see in a minute how does it work. How much time do we wait our client wait until we can say, okay, the data has been written in enough nodes. It's called the consistency level. We are going into it in a few minutes. And
Does that cover the questions you wanted to get to there, or do you have more?
Yeah, maybe about the replication factor. So replication factor is held at the key space level, and you can totally change the replication factor. You can alter key space, with replication and increase or decrease the replication factor. If you do so, then data will be replicated using the gossiping protocol, peer-to-peer, exchanging the data and moving the data when it needs to go.
I laughed there because Kulov in the Discord chat said RF0 means no data, lol. That's really funny. Oh, that's great.
You know what? But there is a way to set up Cassandra fully in memory.
Yeah, it should be pointed out, by the way, that an RF of 3, so as Cedric just explained, right, what the replication factor is. In our examples, you're going to find that we use a replication factor of 3 as the standard. That is the standard. Honestly, there's no real good reason you should go less than replication factor of 3. And if you're doing anything else other than that, like trying to go higher 4 or 5, you should really know what you're doing before you start to go there. If you could have a 1,000 node cluster and use a replication factor of 3 and be perfectly fine, right? So replication factor 3 is in fact the standard. So if you're curious, which one should I use? 3. Use 3.
Yeah.
Okay.
It's very important. Yeah. No. I do have again some question about replication factor. Yes. So it's per key space. The default key space, the recommended replication factor is 3. We'll see in a minute. Yeah. But there is no default. This is when you create a key space, you specifically provide the replication factor. You have to provide it. So there is no default.
I just saw a really neat question come in from Alex C in the Discord. We will get to this later in the application development pieces, but I just want to address this. The drivers are also gossiping with your nodes, and they join the cluster just like the rest of your nodes do. And yes, they are token aware. Matter of fact, the drivers by their very default have a lot of the balancing token aware policies and stuff baked right into them. So you don't have to manage that directly as well. So I just saw that and wanted to answer that one. All right, let's see. So RF3, I'm seeing a couple. Yes, the replication factor 3 is suggested. The replication factor essentially is the setting when you create your key space that's going to tell Cassandra how to automatically replicate, which I'm going to talk about right here, as a matter of fact. So notice the image on the left-hand side, right? You see a map of the world, and I have 3 data center rings there that are connected. So another awesome feature about Cassandra is it doesn't just replicate within a single data center. It can replicate across an entire cluster over multiple data centers. And it does this in an active-active fashion automatically. So check this out. So if you look at that on the left-hand side, I have a ring there over like the Americas. I have one in EMEA and one over in APAC. So this would comprise, these are 3 separate data centers in a single database. This is one database. So what's really cool here about the replication and what it does for you is once this is set, if I wrote some data, say over there in the Americas, that data would automatically replicate out to my other rings and automatically be available in those other regions. So I could write some data over in the Americas and immediately read it from China or wherever it was, and vice versa, right? And this is happening automatic for you at speed of wire, right? So there's obviously physics that come into play here. There is going to be latency if you're going, say, from Australia to the United States or something like that, right? So this is exactly why this is so powerful, because you want to be able to place your data in your database as close to your users as possible. If I had a single data center with like some database just sitting in the West Coast of the United States, but I had a whole ton of users in Australia, they're not going to get the greatest experience because they're always going to be incurring that latency that is just, again, physics limitations, right? So what Cassandra allows you to do is you can place data centers throughout the world into different regions, putting your data where your users are. Then you have your application instances that are talking to those, but you let Cassandra essentially handle the hard work for you for the replication, getting data where it needs to go. On the right hand, do you have something you want to say?
Yeah. Again, a lot of question about the replication factor. So in a Cassandra cluster, indeed, you can have multiple rings. We can see it here. When you define a key space, you define the replication factor for each ring. Okay, you can have a dedicated replication factor in each ring, and depending on if you can easily lose a node or not, you can increase your replication factor 3, 5, 7. But what's the point to have your data present 7th time? The reason we replicate the data is mostly if you lose any of the node, data is still there, and also. Which node to pick? You need to replicate. How do I know on which node I replicate? When on a table, you can have up to 2 to the power 63 rows, and those are evenly distributing around the nodes. So for a ring, each node is in charge of a token range, a portion of your table. And so when the coordinator is requested, he will hash using a hashing function, and know based on the value, it's an integer, based on a long, based on the value, he will know on which node should this data be stored. It's hashing mechanism based on token, and it's working per table. I think I've covered almost 5 to 6 questions.
Yeah, and I just saw a question come in. What do the numbers on the nodes mean? So I'll just address this again real fast. Let me pull back here. Okay, all these numbers this is just an illustration. Please do not take away from watching this that these are like absolute values that nodes get or something like that, right? These are just the token ranges that each of these nodes have been assigned. That's all these numbers represent, right? And by the way, in a real cluster with real token ranges and everything, not like this kind of contrived example, these might vary quite a bit compared to what you see here. It's just the token ranges. It just says, here is the slice of the pie that I am going to take data for. That's all those numbers mean. Okay, so moving over to the right-hand side of this one. So not only do you have this...
I'm in front. No,
what'd you get? What'd you do?
No. Let me disappear again. Yeah, let's do it properly,
Oh, you were in front of... I see. Subject disappeared. Okay.
I was on premise.
So on the right-hand side with the hybrid cloud and multi-cloud, this is another really cool feature, is that, yeah, you can distribute Cassandra all over the world, but you can also distribute it wherever, on whatever installation, implementation, hardware, whatever you want. It doesn't care. So it could be on-prem, it could be in any of the cloud providers. You could have a single database. This is what we're illustrating here. You could have a single database that spans Azure, AWS, Google Cloud, and your on-premise system, all in a single database. Just think about what that means for a moment. Think about if you have a case where, if you're in the e-commerce world, you have to deal with things like Black Friday, where you need to burst up for a time, and you've got your on-premise hardware, but you need to burst up for a time and then pull it back down. That's a great use for cloud, right? But you could have a single database. You could just create another data center right in the cloud provider of your choice, in with that same database that you have on-premise, and boom, now you've got your burst, and you can remove it when you're done. Maybe there is some functionality in the Google Cloud or something that is specific to what they offer, and you need to get data there to be able to leverage that or something. Maybe you're trying to, kind of reduce vendor lock-in. We see this a lot, actually. We have seen more and more folks that are creating clusters that span multiple cloud providers, so they don't get strong-armed by any one particular vendor compared to another. So the point is, Cassandra doesn't care. It doesn't care where you put it. You can put it anywhere, and you can do that with a single database. It's really pretty powerful. Okay, so I want to move into consistency now. Now, there is a relationship between your replication factor and consistency, right? Let's take a look at what that is. So let's see, how many folks are familiar with the CAP theorem? Should I even ask this and have people say stuff in the chats, because the the chats are already blown up, and I'm afraid that it's going to go crazy. But if you haven't heard of the CAP theorem before, essentially what it says is something like this. In a distributed system, in the case of a failure scenario, you can only ever guarantee 2 of the 3 items that you see there: consistency, availability, and partition tolerance. This is not a Cassandra thing. This is any distributed system. So let's break down what this means a little bit, right? So imagine I have 2 nodes, right? And I have a network partition. Something happens, the network is severed. It's always the network, right? Network is severed, and now these 2 nodes cannot communicate, right? Well, in Cassandra, what's going to happen is both those nodes can still facilitate requests, right? They can still facilitate requests, but they cannot maintain consistency because there is a network partition. This is what we're talking about in the case that I can only maintain 2 of the 3 guarantees in a failure scenario. By the way, if there's no failure scenario, everything is humming along nicely, you can maintain all 3 of these, no problem. Now, Cassandra defaults to what's called an AP system, an availability partition tolerant system. That means that Cassandra, by default, is going to be available. Even in outages, it will be available. This is, a lot of times you might hear it's called the always-on database, right? This is why that is. So it is defaulting to ensure that if something goes wrong, it's available and it can facilitate requests and your app doesn't go down. Now, you can configure it if you want to be a CP system, right? Where you essentially put the focus on consistency. What's really cool about it is you can configure this per query. This isn't like a database setting that you have to be CP or AP. This is per query that you can do this if you so need. But again, Cassandra will default to being availability and partition tolerant. So how does that come in a consistency level? Okay, remember our replication factor from before. You'll see that on the left-hand side. Now, replication factor of 3 is the standard, and that's what we're going to use for all of these. So here's the relationship. Replication factor says how many nodes data is going to go to. So if I have a replication factor of 3, regardless of my consistency level, I'm going to replicate data to 3 nodes. Now, if you notice on the right-hand side, it says CL equals 1. That's consistency level equals 1. So I'm saying I want a consistency level of 1. All I'm saying there is, in the case that I'm writing at a replication factor of 3, and I'm writing to these 3 nodes, all of them are going to send their acknowledgments back that they wrote that data back to the coordinator and back to the client. However, in a consistency level 1, I'm just waiting for one of those acknowledgments. That's it. I'm just going to say, oh, okay, one node acknowledged the write. I'm good to go. I'm going to move on. Now, if you take a look at quorum, quorum is majority, right? So it's really the number, your replication factor divided by 2 plus 1. It just means in a case of replication factor of 3, a majority would be what? 2, right? So we're just saying majority. So what does this mean? Well, again, replication factor is 3. I'm still writing to 3 nodes. That hasn't changed. However, I'm just going to wait for 2 of those acknowledgments to come back before I say everything is okay. How about an all? Consistency level of all. What do you think is going to happen? Right? I'm going to replicate to 3 nodes. I'm going to wait now for all 3 of them to acknowledge the write before I continue on and say everything is okay. As you might imagine, as I increase my consistency level, I'm also going to slightly increase the latency that it might take to wait for all those acknowledgments, right? So there's a balance point here. There's another thing I want to point out about a consistency level of all. Imagine what happens in an all if I lose a node. I can't maintain that consistency, right? So we're going to talk about this here in a moment. Something called immediate consistency. Immediate consistency is essentially saying this. When I write some data and then I read it right after, I expect that I'm going to read what I just wrote, right? And so most of us, I think that's what we're expecting. And that is absolutely achievable with Cassandra. So what it comes down to is if you want to achieve immediate consistency to ensure that you can read what you just wrote at any given time, even in a distributed system, you have the number of reads plus the number of your writes. If they're greater than your replication factor, you're good to go. Let's take a look at some examples. So one way to achieve immediate consistency is to write at a consistency level of all, again, where I'm acknowledging all 3 of my nodes at a replication factor of 3 have gotten the write and sent that back. Then I could just read at a 1. I'm guaranteed at this point that I will be able to get the data that I just wrote because I wrote to all of them. But as I was kind of alluding to in a moment ago, because I acknowledged all of them, I should say, sorry. As I was alluding to a moment ago, I have no availability tolerance here. If I lost even one of those nodes, I would not be able to write at a consistency level of all. So that's not really a good trade-off. Cassandra is supposed to be robust, be always on, right? So how can I achieve this with having my availability tolerance? And this is where reading and writing at quorum come into play. So if I write at quorum, meaning I'm still writing to all 3 nodes, but I'm just waiting for 2 to acknowledge it, but then I read at quorum. This is kind of neat because now I can tolerate a node going down and I can still facilitate my reads and writes with no seeming effect to the system, right? What's also cool, and this gets into a little bit of the weeds, that when you read at a quorum, let's pretend for a second, just pretend that for some reason that like that node at the very bottom, that doesn't have the check mark, let's say it had stale data, right? When I read at quorum, an automatic checksum and comparison is actually made. So what'll happen is that for some reason, any data is seen being stale or something. Not only will the correct data be sent back to the client, but the stale data will automatically be repaired. This is part of the self-healing mechanism that comes with Cassandra. But the key thing is that you get that when you're reading at quorum. So the standard here, by the way, just like we said before, replication factor of 3 is the standard. The standard here is read and write at quorum. This is a good balance between latency, between availability tolerance, all of that. And again, unless you have a really good reason, just do this and you're going to be in a really good place. Cedric, do you have anything you want to add to that?
Astra feels better. It will be ready in a few minutes or this minute. It was due to authentication issues. So, the Cassandra database under the hood, of course, are working very well. It was mostly authenticating against the platform who was lagging behind.
Okay, yeah. Okay, and so I'm seeing some questions. Might as well take a moment to kind of answer those. I see one here from Anu Sharma in YouTube chat. It says, how does the CL quorum for read decide which node has the correct data? So it can read because in a case when you're reading and writing at quorum, that's the key thing, because I'm writing at quorum as well, right? I have this automatic overlap, and that goes back to that equation. Oh, sorry, I moved my mouse. It's not an equation really, but here, aha, this goes back to this. Remember I said if the number of reads plus the number of writes is greater than your replication factor, you have immediate consistency. So remember in our examples, the replication factor is 3. So if we go back to this, well, if I write it all, that's 3. I read it 1, that's 4. 4 is greater than 3, right? In the case of quorum, it's the same deal. I'm writing at 2, I'm reading at 2, that's 4 greater than 3. What that really essentially means is I have overlap. So it doesn't matter which 2 nodes. It just doesn't matter which 2 nodes are being read from. I only need one of them to be right. And since I wrote a quorum, I'm guaranteed that I'm going to get that scenario. So if I had 2 nodes that I read from, and one of them was stale and one of them was right, I'll get the right data sent back, and then I'll automatically repair the other one. And like I said, there are other, without going into all the details here, there are other mechanisms underneath the hood that are doing checksums and comparisons and such to ensure. But it is a guarantee to let you, to guarantee that you will get back the consistent data. It doesn't matter which 2 nodes are read from in this scenario, right? If I was writing at a 1 and reading a quorum, that might be a little bit different. But since I'm writing a quorum and reading a quorum, this is the way that you can achieve that. Hopefully that answered that question. Okay, let's see. What else do we have coming through here?
Yeah, I've had a hard time keep up. Oh, so maybe
yeah, so many questions.
Yeah, I will be quicker by doing it.
Yes, the live session is getting recorded. The video will be available right after this in the YouTube feed.
Yeah, so you, David. Oh, hello, David. What's happened to you in Florida? Can I see you?
Oh, here we go, Cedric. The Skype popped out for a second and popped back. It sounds like you asked me something.
Yeah, no, we lost you for a minute.
Yeah, I'm back. I'm here.
No, that's...
Sounds like you can hear me.
No, that's okay. So I was answering a question about data center. So we don't need multiple data center per cluster. You can have one, that's totally fine. And why would you do multiple data center? Well, maybe due to the law. You want to have a dedicated data center, you know, you live in Germany, you want to have a dedicated in Germany because this is a law. You need to have the data close to you, close to you in the same country. Or you want to have the data close to the client app. I mean, I'm using Uber. Uber is famous for using Cassandra a lot. So if I'm in North America and using Uber, I would like to connect to nodes close to me just to reduce latencies. And same if I'm other part of the world. And you can read and write from everywhere, and Cassandra will replicate from one ring to another asynchronously using yet another consistency level dedicated to data center. We won't go into the detail. They are in DS201 you should take as a homework after this session.
Okay, and I was just catching up on some questions that I saw. Let me go ahead and get back to over here. Okay, so, all right, so this is the standard, right? Is again to read and write a quorum. You're going to be in a good balance between, like I said, latency, availability tolerance, all of that. There is another, it's weaker consistency or called eventual consistency.
Just interrupting you again. Astra is back. I mean, you can go to the status page. Fix has been deployed. You can now try to create the database just to be able to do the exercise after that.
Okay, good. Well, then once I'm done with this, then we'll pop back over and we'll go take a look. Thank you.
Wonderful.
So there is another example here, weaker consistency, or what's called eventual consistency. Really, all this means is I'm going to read and write at a 1. Right? This is the fastest way to do it. However, you do not get some of the self-healing mechanisms and some of the same guarantees you do with quorum and immediate consistency. Now, for some cases, this might work wonderfully well. Let's say you're just, you've got a part of your data model that is responding to like the number of likes or something. Does that need to absolutely be consistent or something? No, right? So could you read and write on 1? Totally. And funny enough, Netflix is a big power user of Cassandra, if you didn't know that, by the way. When you're using Netflix, you're totally using Cassandra. and it's
Yep.
awesome what they
Yep.
do with it. Netflix is such a they're just like they know their stuff. Netflix did so many years ago. They did a talk on this actually, and they tried really hard to get inconsistent results at reading and writing one, and they couldn't do it. Right now, we will never say that then it's okay to just do it. If you have a requirement for immediate consistency, use quorum, you're good to go, right? However, if you don't have that particular requirement and you have a particular part of your application that needs to be fast and you can tolerate having stale data by so many milliseconds or something, this might be an option. But again, just like I'm saying for replication factor, stick at 3. If you're doing something else, you really need to know what you're doing. Here again, stick at quorum. If you need to do something else, then you need to know a little bit more just to make sure you're setting the right expectation of what you want. So quorum is your friend. Okay, so with that, let's go. Like I said, we're going to go take a look at the Astra thing, see how this is going. Let me refresh. We'll go back.
Did you hit timeout?
I did. Yeah.
No
but
problem.
Okay, here we go. Oh, here,
but,
let's.
it
created. Funny enough, even though that one part died for me, it still created the key space or the database.
All right. Yeah, it was due to the out system. So
yeah, it wasn't the database part.
No, the database were fine.
So I'm going to go back though. I'm going to go ahead and terminate mine so people can follow along, not follow around. That was new. We'll go back here. Okay. Oh, good. I see some nice answers coming through. Great. Refresh my thing here. All right, let me see if it will.
Okay, and to know the values to enter to the form, they are on the GitHub repo. It's killer video. Yeah, you got it. Yeah, probably we will share that link again.
But
that's
I could probably put
bigger
in the anchor, can't I?
Yeah, and make it bigger as well. So the value is killer video. So let me put that in the chat. But the chat is moving so fast.
Yeah, here, let me make this bigger. So for those of you who are getting back around to creating your Astra database, then here are the values that you need. Again, this is in the GitHub repo. Cedric is going to go ahead and drop those links for you.
Oh, the link, yes, the link as well. I just provide the value, people like to just copy paste, but I will do the link as well, of course.
Here, I beat you to it this time.
No.
Aha!
Yeah.
There you go.
Teach people how to fish instead of giving them, fishes.
Let's see. There we go.
Right.
So I can create my new database. So I'm going to go ahead and do this with you. Again, choose the free tier. Choose the region that is closest to you. I'm going to fill the database name.
Here is the link. Boom.
Okay.
No, the chat is on fire. Also, the link is below the video.
There's a million links. You can pick any of them.
Yeah.
Key space name is killer video. And again, this is just for what we're working on. You don't absolutely have to do this for your own databases, but we do ask that you use these values for what we're doing here today. Yeah,
so the database should be created in 2 minutes, something like that, especially for the free tier. We are spawning a single node. So yeah, 2-3 minutes should be fine, even if there is a message telling you that it should be 20, not at all.
Yeah, the message is just there. I think, honestly, it's kind of a holdover. Usually it just takes a couple minutes. So here, you should, hopefully, once you fill out those details, you hit Launch Database, you're going to see something like this. You say View Database. Then you should see this screen, right? As a matter of fact, if we go over here, let's see if we can try this again. All right. So how many of you, if you can, here, I'm going to do it right here. Yeah, if you could, give me a thumbs up if you are at that screen that I was just showing a moment ago. I want to see if we're doing better now. Okay. And while we're waiting for those thumbs up, let's see.
Yes, so...
Oh, I see a bunch coming in. Good. In the Discord, wonderful.
Oh, do you want me to hide? But even if I add, I do have the Skype logo behind me, so I will stay here. And you have to tell us how many thumbs up you have.
Right now we have 258. I'm seeing a ton coming to Discord. I'm seeing some in the YouTube chat. By the way, if you can, we should drop the Menti stuff as well. Was it 45, 45, 72?
Yeah, 45, 45, 71. Okay. But at the same time, I'm just picking random question. It's screening so fast.
Yeah. Oh, so there is a replication factor in Astra. I just saw a question from Atul in the Discord. So in the free tier, this is getting a little bit into fun details. In the free tier, the replication factor is effectively 1, right? Those are single node instances. It's for the free tier. Those are meant to be kind of like, I'm just spinning something up and I'm just testing it, playing with it or whatever. Once you get to the other tiers, they go to your normal replication factor of 3 with the right amount of nodes and everything. So there is a replication factor in Astra. What it is, though, is the Astra is built to make it essentially a push-button, single-click experience to spin up your Cassandra database without having to deal with all that. You'll notice, and I'm going to talk about this later, you don't have to create the key space directly either. You put you put it into a field and say launch. All of that is hidden in the implementation. It's being automatically done for you. That's where that's coming from. Yeah, if you're seeing the launch database button is grayed, I'm seeing actually a ton of folks.
Yeah, it's coming. It's coming. I see a lot of people. So
yeah, we'll give it just a second there.
Yeah, on the free tier, so the settings of Astra is a single node DB with replication factor 1 because there is a single.
That's right.
And you cannot go to Cassandra.yaml and all the small details. It's Cassandra as a service. But still, you will see in a minute that we will use something called DataStax Studio. And you also have the CQL console. So if you're familiar with Cassandra, you can go with it.
Okay, so I'm going to go ahead and move on. I saw a ton of you. I think we have at least like 500 folks that are in where I would hope they are. So I'm going to move on, and we're going to give that a moment to let those databases come up. Yeah, and here's the thing, everyone: if you're not able, if your Astra database hasn't come up just yet, or whatever, or that's okay. Right. You can always follow on after this. The stuff was all available online. You can always reach out to us if you need any help. So don't worry about that. Okay. So go ahead, Cedric. Do you have something?
Can you go back to the previous slide? I will make it very quick.
Yeah, go ahead.
No, I would like to talk about vocabulary. The slide with the hybrid cloud stuff before. But if you can go back there, that's totally fine. So the biggest term in Cassandra is a cluster. A cluster is composed to one or multiple rings. What you see here on screen is one ring composed with multiple nodes. Okay.
Right.
When you create a key space is like the logical database you want to put in Cassandra. You can have, of course, multiple key space in a Cassandra cluster. So when you create a key space, you say on which data center this key space will live, and for each one you will provide the replication factor. Yeah, I just refresh about the vocabulary.
So Rishi in Discord asked a question, and apparently my fingers did not function properly when I typed him a response. I meant to say for today, yes, please, not for today, yes, please. Yes, the question was...
fat finger, that's totally you.
Yeah. The question was, do you need to create the database with the same details provided in the GitHub repo? Yes, today, yes. Again, because all of the exercises and such that we're going to be using are going to be based off of that. And if you don't use those values, it's not that it won't work, but then you have to go and change a bunch of data model stuff. It's not going to be very smooth for you. So again, use the values in the GitHub README for today. If you're doing your own thing, you can do whatever you need. So Cedric, did you get what you needed on the slide here?
Yeah, totally. Just do a reminder because I got you. So when you switch to GitHub and showing browser mode, people ask to make your font bigger.
Oh, okay. For font bigger for which one? The README?
Yeah, probably the README, but also Astra.
Okay.
They can barely read.
Oh, really? Okay, got it. All right, I'll make it bigger. Thanks, guys. Thanks for letting me know. Okay.
All right. So now it's a big slide. I love this slide.
Yeah, this slide. So Cedric's probably gonna have a lot he wants to say here. I'll just give a very quick high level and let Cedric kind of dig in for fun.
I can
So
make it.
Well, what's that?
I will make it, you know.
You want to just go?
Yeah, let's go.
Go for it.
Yeah, let's go.
Are you do it?
Okay, so show me the first line. Again. Okay, so what we want here to show is based on the capability we have explained to you about Cassandra, then you do have dedicated use cases. So first, scalability. We told you you need more capacity, add new node. You have more throughput, add new node. So first range of use case for Cassandra is high throughput, high volume. Every read, every write. So if you have already heard about Cassandra, it's probably for one of those use cases. Internet of Things, event streaming, time series. Why? Because those use cases need to write the data very, very fast. And Cassandra is famous to write the data very fast. Second capability is about availability. Can you make it visible, David? Yeah, all right. So the data is replicated and there is no master. So you can lose any of the node. It's not a big deal. So the system is always on and there is no data loss. And we had a question before how the int working. So it's also in DS201, but the coordinator node will store on disk data that has not been sent to the replica. And replica, when the replica go back online, we just stream what the replica missed. Okay, so with those use cases, I mean, any use case wants always on no data loss, especially, you know, caching, distributing the market data, pricing inventory. Okay, let's move.
Oh, I gotta stop real quick. Sorry, Cedric. Gender just asked me a DM how to implement SSL for this, and it's actually one of the. We're not going to get into it today. In weeks 3 and 4, are we going to hit on those in the app dev stuff, Cedric?
Absolutely. Week 3, we will just explain how to, you know, how we connect to Astra using the driver with SSL and double certificate authentication. Totally.
So one of the things I mentioned that Astra was built for developers, right? And anyone who's ever done SSL in Java especially knows the pain. It's so challenging, right? So we removed essentially that layer completely and added as what's called the Secure Connect bundle. We're going to get into this in week 3 and 4. But when you create your Astra database, you're going to see there's a link for the Secure Connect bundle. All you do is download that. That has all the artifacts for TLS, you know, the whole secure connection piece is there, completely configured for you to handle a secure connection to that database, right? It's extremely easy to use. So we're going to get into that. And I had to stop because I got so excited when I saw that question because it's, honestly, it's a really nice feature. It significantly reduces the time you have to mess around with anything really to get a nice secure connection to your database. Anyway, sorry.
No, but you know, that's a point to do this event live. We can stretch a little bit, we can be late, you know, it could be 2 hours and a half, but yeah, we love to answer your question live. That's the point of the event. Okay, so let's go to the next line. So after availability, it's distributed. So remember, you can distribute nodes all across the world, or, you know, using multiple cloud providers. So now this is a solution to have one data layer available in all the cloud. It's distributed, okay? So why would you create multiple data center? I told you that already. Low compliance, GDPR, or, you know, to reduce latencies because you want to have your application to be as fast as possible. And so Cassandra can have the data available everywhere, anywhere, and you can read and write from, you know, anywhere. And Cassandra will replicate asynchronously, remember, and will make your client wait depending on the consistency level you ask. You can wait for one node to have been updated, the quorum close to you, or the full cluster. You decide. And of course, how much consistency level, higher the consistency level, longer will be the response time. But you can totally achieve consistency. And last but not least, and probably the most important, so let me show me the last part. Yes.
I'm answering questions. And
you can do.
Sorry,
yeah, so next time I will just take over the slide.
Yeah.
Okay, so, and you're hiding, so don't, okay, I will hide you for a sec. Sorry about that. So it's about cloud native. Okay, so now you see that Cassandra can be installed on any cloud, right? And with the drivers, you can build any kind of application on top of it, real-time application, API, microservices, and of course, because now everything is compliant with Kubernetes, you can not only deploy your app, but also the full Cassandra database also in Kubernetes. And this is now why we will tell you weeks after weeks that what we are building is a cloud-native application. So not only your code, stateless, API using your the language you like, but also the database. You should have to worry, where is my data, how to connect to. Cassandra is there. You do have the bunch of nodes close to you. Simply use the data, where is it? I know, hybrid cloud, multi-cloud. Okay, so let me put you back, David.
Oh, I'm back. Am I back?
Yes, yes, you are.
So I'm seeing a couple questions, by the way. Some folks are asking, what happens if they terminate the key space or terminate the database in Astra? Will they lose their data? Yes.
Terminate
so,
this.
Yeah, if you're terminating it, you're not just dropping a table or dropping a key space or something. You are completely terminating the database at that point. Now, that's also part of the free tier, right? That that's kind of part of the use is you can kind of create and terminate things as you wish without having to worry about the data because it's a free tier and you're kind of just doing things for test. But yes, to answer, if you do terminate it, you will lose your data. If you want to change the key space name, right, you need to recreate it. You will need to terminate it and recreate it. Again, being a fully managed system like this, there's a lot of underlying details that are being assumed and done for you. Now, even in, if I'm right though, even in a regular open source Apache Cassandra, I don't believe you can just rename the key space anyway. You'd have to recreate that, if I remember right. Yeah, I don't believe you can just change the key space name right off the bat. Now, not even a table name. Yeah, you have to create a new table. So, and we'll get into more of why that is actually a little bit later, because you're going to see that when you're changing your key space, you're doing a little bit more than just messing with the name. Let's see. All right. So I saw a lot of folks did, in fact, get their Astra instances up. Mm-hmm. So what I'd like to do now is go into the first exercise. So what we're going to do, now remember before, we had you either download the zip or clone the GitHub repo. So that means that in there, if I go ahead and do this, right, you should have a notebooks directory in there. This is where these are going to come into play. So here's what we want to do. And by the way, this is all within the README itself. I'm just walking you through it, right, so you can see it. Oh, and I've gotten reports that my font is too small. So here, hopefully you all can read that better. I will blow that up a little bit. Okay, so here's what we're going to do. Hopefully, once you are at this position, right, or if you see something like this, you can just click on the database itself, and you'll come to the database detail screen. On the left-hand side, if you scroll down, there's two ways to do it. You'll see an Actions dropdown. You can click on that, and you'll see either a link for Developer Studio there, or you'll see Developer Studios down here, and you say Launch Now, right? Either one will work. If you click on that, what it's going to do, it's going to spin up an instance of DataStax Studio, automatically configured to talk to your Astra database. This is actually really cool. So here, this is one of those areas where we asked you to use the username and password we put in just so it makes it easy for everybody. You're going to use the same username and password that are from the instructions. So again, capital KV user and KV password. Say test. And that'll take just a moment. There we go. I'm connected successfully. Wonderful. I'll hit save. And then once I do that, then that's it. I'm now connected and ready to go with Studio. Do you need to shut down? Oshin, do I need to shut down my Astra instance if I'm logging off? No. Your Astra instance is going to run automatically. You don't need to shut it down or anything. Over time, it will park itself for you. And then when you come back to it, if you're not using it regularly, it'll, you can unpark it and such. But you don't need to turn it off or do anything like that. It's completely running on its own, fully managed for you up in the cloud. So you should be good. So once you fill in those details, the username and password, you do this, that's it, you're connected to the studio. So here's what I want you to do next. This is actually really neat. So remember, again, we pulled, again, you cloned or you download the zip. So I'm just going to go ahead and pull up my Finder because I'm on a Mac and the Finder is funny as far as I'm concerned. And I'm going to go to my directory, Cassandra Workshop Series Week 1.
Yeah, so you will import the notebook.
Yes.
Okay.
So here's what's really cool. You could do this one of a couple ways. You could click on this plus, or you can just drag and drop it. So I'm just going to grab it. I'm going to pull it right in there. Again, if you did this in the zip, or if you did this through the git clone, it doesn't matter. I just want you to go to that number 2. Let me pull that up again. Can I use that same zoom function in here? Oh God, you can. So this is going to be DataStax Studio. You'll see this tar ball. This is actually the Studio notebook itself, right? You can just drag and drop it right on there, and it should bring you to a page that looks like this. And just like we did before, I'm going to move this forward. We had all those. Here we go. So if you could give me a thumbs up when you get that going.
Yes, I can tell you that people working because the chat is calming down. Still some folk have issue connecting Astra, but you know, for most part it's okay. I think that I can interact with Astra pretty fluently. So people are working. I can see also some extra question during that time, as usual. So difference between key space and databases. Okay, so in a Cassandra cluster, you can have you can have multiple key spaces. And yes, let's say key space are like, you know, database for Oracle or schema for Oracle. You know, it's not exactly the same, but that's really the logical grouping. Okay, when you connect to Cassandra later with the driver, you can provide a key space, and then you will only see the tables living on that key space. You will create object with a key space scope. Okay, so the best practice is actually to create one key space per, you know, either application or use case, because it's kind of, you know, bounding context, a business context. Every object, so tables related one to each other, should fit in the same key space. Okay. Yes.
Okay. All right. I see. Do we have a session event tomorrow? No, the next session is going to be next week, right? Yeah. So we'll do one of these live sessions each week. And all right. So good.
No.
All right. Good. I'm seeing a few people here.
We will be live tomorrow, David. Not us, but you know, a couple of other
folks
from DataStax will
be. Session for the APAC and EMEA reading tomorrow on Thursday.
Alex and Eric will be there tomorrow morning my time to do so 12:30 IST, you know, time zone, doing the same content.
Yes, same content and everything. Okay. I see a question, which program do you use to open the MD file? You're going to want to open that. That's really meant directly for, it's a README, so it's really meant to be opened directly in GitHub. So if you open it directly there, if I go back over here to the GitHub, this is the README itself, right? So when you actually click, if you were to go to it, the README, it would actually bring you right to that README, right? That's all that is. So I'm sure there's readers out there that'll allow you to do that.
Yeah, so can you mimic again the import notebook procedure?
Yeah, let's do it. Let's totally do it, yeah. So
and put your screen bigger, you know, huge font.
Do you want me to do the drag and drop, or do you want me to do
the drag and drop with a huge font.
Let's do drag and drop.
You know, huge font.
Yeah. All right, so what I did is I went to the Cassandra Workshop series folder that I Git cloned, but you could have downloaded the zip.
Yes, so everything that you have downloaded. So you will pick something, a tar file, okay, in the notebook folder. Yes.
Yeah, week 1, getting started with Cassandra, to notebooks, and then the one we want is DataStax Studio tar. This is one that says 2, right? 2 DataStax Studio tar. All I have to do is pull that, drag and drop it. Now I've already got one, but boom. It'll go ahead and it'll automatically import it. Notice I have another one now.
Yeah, for those asking, you don't have to install DataStax Studio. On the home page on Astra, in the bottom, I think it's on the left side, you have something called Developer Studio, Launch Now. Okay,
right here.
And if you're here, then you will be moved to Studio. You will have to provide, again, user and password the first time. Remember, KV user, KV password, and you should be good to go.
Okay. Yeah, I saw a couple people saying GitHub zip is not extracting completely. That's really interesting. You know, Vinyak, we'll talk about the homework and assignment after. We'll get there. Okay. All right, yeah. So then you hit launch now, and once you've done that, it should
Yes,
connect.
so why are we dropping? Well, this is the exercise. So DataStax Studio is a notebook-based tools. So the exercise is a notebook. So what we will do is we import the notebook as a tar file. And next, we open this notebook exactly as you would do with Jupyter Notebook or Apache Zeppelin, same kind of tool. And in there, by the way, the first exercise is really to make you discover what is DataStax Studio. And as you can see, you create cells. Some have markdown, text, and some have Cassandra commands.
I have to say, so Gerard Ghislaine on the YouTube chat just pointed out, I think I just realized that for Windows users with the zip, some of our file names might be too long. So we'll have to fix that.
Oh.
They might be having an issue. This is what happens when you have people on Linux and Unix-based systems. We're like, oh, file name, whatever. We can just do whatever we want. So sorry about that. If you are having a challenge with the zip, apologize for that. You should, if you need to, if for some reason downloading the zip is not working for you, you should be able to go to the repo itself, go to the notebook, and save that out, and then use it that way. You should be able to do it that way.
Yes, okay. So some people validating that indeed, yes, on Windows, please download the zip on C drive,
Windows drag and drop
C
working
semicolon,
fine.
And the file path should be short enough for you to import it.
Oh, I think we just started a Windows Linux war here.
Oh no!
Mac war. I didn't mean to start a Windows Mac war. Oh, no. Yeah, there are other zip tools. Thank you everyone for your comments there to help folks out. That's wonderful. Thank you. Those are really good comments in there I'm seeing. Great. Okay. All right. So with that, hopefully at this point you're able to get to this first notebook, right? And again, you should see something once you open it up. You'll see it. If you see it like this, you click on it, or once you first import it, it'll go right to the notebook. This is already hooked up to your Astra database at this point. You don't have to do any more, right? So what I'd like to do here is I'm just going to kind of bring you through this particular notebook so you can kind of follow along if you wish, and just point out how these work, right? So you'll notice that we embed a lot of, there's markdown in here. You'll notice that each of these cells I have markdown or CQL. So you'll see that we do a lot with the markdown to kind of give instructions. So everything that you need in the exercises in the notebooks is going to be right here in the notebook itself, right? So now I'm not going to read all the text and everything. I'll let you guys do that all on your own. But what I do want to point out is you'll see some links like this. This is just in, kind of a practice letting you know that we're doing this. A lot of times what we'll do is we will put solutions in an expanded section like this. So then if you choose, you can look at the solution, or if you want to work at it a little bit, don't, right? So it's up to you. All the answers that you need are always in the notebooks. They're always there. They might be in one of those expanded sections. So something else I want to point out, and you'll see this big obnoxious red arrow. This is just in this particular notebook. Here's what we're saying. In the beginning of each of these notebooks, the way we've set them up is it looks like it's an empty cell, right? Yeah, I'll talk about the Schema Explorer in a moment. I just saw a DM coming for that. Mm-hmm. You'll see a first cell that looks empty. Really all we've done is we've just hidden the code, right? Now in this first example, it's not doing all that much. And so you might be like, why would you hide that? You're going to see in the following examples, there's a lot more data model and everything going on. So instead of making everybody scroll all down and everything, we just hid that. Just know that when you start the notebook, the very first cell, it looks empty. You just want to go ahead and execute that. You'll see something just like this where it says, success. That's it. That's all you need to do. That sets up your data model. Oh, what do you see, Cedric?
No, I just see Windows rules, Windows rules in the chat. Yeah, and, so with 7-zip or NRAR, you manage to untar what you need, unzip what you need.
I do see a question about can you elaborate on CQL? We're going to do CQL in these notebooks.
Yes, CQL is the next exercise. Oh, so we may be a bit late. You might tell. We took a lot of questions and stretched a little bit due to the Astra issue. So yeah, maybe let's say 30-minute-ish, maybe.
Yeah.
But hey, we do have fun.
Yeah, and I'll say this. If you can't stay with us after 2 o'clock or after whatever time is in your time zone, but if you can't stay with us after the initial 2 hours, that's fine. All the stuff is recorded. We're online. All the materials are there. We're gonna, you can always watch it later. But if you can, please stay with us. We're gonna continue through the
Yeah,
material.
we will give you the solution of the exercise in the last minute.
Yes, and
no, just kidding.
Don't forget, we're gonna have some fun quizzes that you get swag for if you win. So that is coming up. All right, so let me go ahead and just burn through what's going down in here. So really this notebook, this DataStax Studio notebook, is just getting you set up with how to use DataStax Studio. So again, I'm not going to read everything that's in here. I'm just going to kind of go through and give you the highlights. So as you noticed a moment ago, I was actually using the Markdown editor. You'll see that in each of the cells, you have this little eye that's showing the code, right? So you can determine if you want to do that or not. Now, this particular one is actually kind of explaining how to edit Markdown. And you'll notice if I go to the bottom, it says, hello, your name goes here. So it's essentially saying, all right, let's go down and change the Markdown. I'm going to say hello to Cedric. It's weird saying hello to myself, right? And then I'm going to go back up. Now, what I'm going to do is I'm going to play. I'm going to run the cell or play it, if you will. And notice now that here it says hello, Cedric, right? So whether it's Markdown or if it's CQL, once I've entered in my code or my CQL, I just run the cell with that play button, and that will execute whatever the statement is. Okay. There are all sorts of other operations you can do. If I want to maximize the cell size, I can click that to maximize. If I want to, if I go to the ellipsis here, you'll see that I have other options. I think they're pretty self-explanatory if I want to delete a cell or move it. These are really nice, actually, for training materials like what we're doing right now. They're also really nice to share amongst colleagues. I used to write engineering notebooks. Now I'll use a studio notebook. I'll have all my queries, all my stuff worked out. And then if I want to share it with the team, I just export the notebook like this. I say export the notebook, and I can just give that tar file just like we have with you. I just pass it to someone else, and now they have everything in there, right? So it's a really nice functionality from that standpoint. And that's kind of what this stuff is talking about. If I want to add a new cell, you see these plus, you'll see these plus signs in between all of these. All I have to do is click, boom, I'm going to add a new cell, and I can do whatever I want with it. And then if I'm in a CQL cell, let me go ahead and bring in a CQL cell.
Yeah, let's start with the Cassandra query language finally.
Yeah, finally, right? We're finally getting there. We're finally getting there. But now notice that my language here is CQL, right? So I can actually do something with CQL. And you'll notice that when I do this, it gives me this key space piece, because if I have Markdown, well, I'm not interacting with the database at that point. But if I say CQL, I want to, I'll get this key space drop down.
I think you can make it bigger again.
Oh,
can you?
I can try.
Yeah,
I'm working on the bigger part.
Yeah, it's.
I'm gonna run out of screen real. Is that better?
Yeah, potato font. Yeah, okay.
Yeah, so you can see now that I've got this key space drop down that shows up where I can choose between the various key spaces. Now, in my case, I want killer video because that's the one we're working with. Over here, I'm not going to get into too much detail about this, other than you can change your consistency level at any time with Studio. So by default, I'm going to run at local quorum. I could change to 1. But what I really want to point out is trace. Let's say that I want to perform a query and I have some part of the query I'm not exactly sure why it is taking the amount of time it is or something. I don't think we have any data in these. But do we? We don't have users table yet, but we do have user credentials. Yeah, we haven't created users yet.
No. I think if you look at the schema, we don't have a lot yet. Yeah, let's move forward.
We haven't created it yet.
You can simply, I think you can simply describe key space killer video. Just this command will show you what in there. So I think it's good because we will show how to create a key space. So describe key space killer video. So it will show what's in there. So if you drag, okay, so you can see that there is only the statement to create a key space. Create key space with replication, and boom. Here you see, we do a single DC called cast DC, and the replication factor is 1. And again, I'm hiding part of it, so let me Okay, yeah. Enjoyable, right? All right. Okay, let's move forward.
Okay. All right. So
I think we can go on now. Most of people have catch up.
Okay, cool. Good. Excellent. So you'll notice here that that in the dropdown there's a trace. So once we get into the next notebook, this will become more evident why that's useful. But if you do want to trace a query, there's a really nice graphical UI that when you do a trace here, will actually split it out. You'll see nice like duration bars and everything. It really helps you kind of troubleshoot things. And we were talking about the describe key spaces. Now, somebody else pointed out the schema button here. So describe key space is really the way I would probably do this if I was in the SQL shell. But here in Studio, I have the schema button up top. So I can now kind of essentially get what I'd get with a describe. Now, we don't have any tables in my killer video key space. We haven't created them yet.
No.
Right, but once we do, you'll see that populated. And so we'll get into that more into the next notebook. Just know that
next notebook will be much more elaborated.
Right.
Like, I think we can move. Describe key spaces.
I think so too.
It's just describing the tool. I think now everybody got an idea.
Okay.
We already had some summed up about it. Yeah, I think let's move.
Yeah, so we can let me zoom this back down a little bit.
Yeah, right, we need that part.
Yeah, so again, you can always go through these at your own. Now, the cool thing is since you've created your killer video key space and your database here in Esther, this is just going to stay up. This isn't going anywhere after this live session, right? So you can do this at your own speed and take a look, but that just gives you an idea of what's going on with Studio. All righty, so with that, we good to move on? What do you think?
I think we are good.
Okay, so now what we're going to do is we're gonna blast through the read and write path because we did promise you we're going to try to get through things here by 2:30 or so.
Yeah. Oh,
and Jack, yeah, my bad, Jack. I'm sorry. We haven't actually ended yet with the quiz. We do have the data modeling piece. So we will get there soon. All right, so let's get through this read and write path. So I'm actually going to start with the write path itself because this is the one that's directly tied to what's happening with those acknowledgments. And when we were talking about consistency level before, and I said it's going to, whichever one's acknowledged back to the coordinator first. This is just the acknowledgement that I'm talking about. And this actually kind of illustrates some of the really cool features that Cassandra has as well, some of the things it's doing for you. So when you write data, when you're writing something to Cassandra, it goes to two places, both RAM and disk, and what's called the mem table and the commit log. Now, what I want you to notice here, this is a row of data, right? We have some row of data that's coming in. When I write that to a node that is being written both to memory in the mem table and the disk and the commit log. Now, they have different functions, though. The commit log is append only, and its sole purpose is to be there in case something happens to the node. That way, I have the data, it's persisted. Because what happens if I lose a node or I lose the JVM, right? I'm going to lose all the stuff in memory. So I need to ensure that that data is persisting on disk. That's what that's for. Then the mem table is going to offer us another functionality, right? And that comes into play when we do reads later, but then also if we're using something called a clustering column. Now, we haven't really gotten into this yet. So when we get to the data model piece, you're going to hear me reference something called a clustering column. Clustering columns are used for ordering or for uniqueness, but for this case, we're just going to focus on the ordering part. So in our example here, our city, Houston, right? That's going to be our clustering columns. We want to order on the clustering column. Let's check out what happens when we get some more data. So by the way, I should mention, when you've written to both the mem table and the commit log, that then sends that acknowledgement back. So when we talked about consistency level earlier, and we were saying that we're, those green check marks that you saw, that when it gives the acknowledgement back to the coordinator that it's finished to write, this is what we're talking about. It means I've written to the mem table, I've written to the commit log. Okay, so let's watch what happens when I get more data. I get another piece of data. Notice the color, right? Watch this. So look what happened in the commit log. The data was appended to the end of the commit log. But in the mem table, why did that go to the top of the list? Because we have a clustering column for order on the city. And when we use a clustering column, it's automatically going to store the data in its ordered format. So since this is a text field, it's going to do it alphanumerically. And we're going to say that D comes before H. Why is this important? Why am I telling you this? Because when you do ordering in Cassandra, your data is being ordered while on the write in memory where it is fastest. Later on, this is actually going to get stored on disk this way. What's really cool about this is that I'm already pre-computing, I'm pre-baking my order. So when I go to read the data later, it's already ordered. If I did this in a relational database, I am paying for the order by at the select. I'm paying for it on the read. But in Cassandra, we're trying to optimize this by paying for it on the write. So when I read it later, it's as fast as possible. And then notice again, the commit log is going to append at the end because we want that data to persist on disk as fast as possible in case something happens. So check it out. I'm going to bring some more in. Another piece of data, different color. It appends at the end of the commit log, and you see it goes into alphabetical order for S, D, H, S. Same thing as I move on. Austin, that last row got appended onto the commit log for persistence, but it was automatically ordered in the mem table. Then what happens when the mem table fills up? Well, it's going to flush that data down to disk in something called an SS table. What I want you to notice, though, is that the data that is flushed out is now ordered. It's actually stored like this on disk in its ordered fashion. And once I've flushed it, I no longer need the mem table. I no longer need the commit log because all my data is now persisted. If something happened to that node comes back up, well, I have my SS table, and that is there in disk. You should also note that SS tables are immutable. So once they are written, they are not changeable. Let's see. I'll have to, by the way, I'm seeing if I can read your DM, and if it's short enough, I can actually make out what you're saying. If not, I can't. So I didn't quite catch that question. I have a lot of DMs, by the way. I will be following up after today to get to your DM. So if I don't get to it right away, let me know.
Yes, and same. We do have a lot of questions on YouTube chat, so we will review the question. Some we cannot answer on spot, and for some we do the full explanation on community.datastax.com.
Yeah, Killer Wolf is asking, is there a limit to the commit log? I'm assuming, are you asking like a limit to the size or the amount of files or whatever? I would say disk space is the only limit I know of. Cedric, do you have anything else there?
There is a limit. You will split. You will split the commit log files based on the size, I guess. There is some kind of threshold, commit log, blah blah blah. But yeah, and that would be also the volume. And you know what? You don't want to have a commit log very large because when you lose the node and you restart the node, the first thing that the node will do is called bootstrapping, and it will reload all the commit log in memory. So you do not want that.
Okay. All right. So again, this mechanism, when you write, this is automatically being done, right? This isn't something you have to actively do, but just know that you're going to write to both the mem table and the commit log. When the mem table fills up, that will flush to an SS table, which is immutable, and it flushes in its ordered fashion if you are using a clustering column.
Oh, very important thing. So I saw a couple of questions about now, the SS table is immutable. What if I want to change one value, lone star has been changed? How do I change that? As Cassandra is append only and the last write win, what will Cassandra do when reading the data? It will take the latest version. It will have multiple values for the same version. It will compare the timestamps and take the latest one. But go for it with the read path.
Okay, cool. By the way, I just saw a question come up asking, is the second notebook they're working with CQL, is that actually part of the 2-hour homework? Originally, no. We did have a hiccup in the beginning that ended up eating some time that is taken away from that. So maybe we do end up making it part of the homework. We'll figure out that notebook is actually going to be kind of key to go through. So I know I'm trying to get through this stuff as fast as we can.
That's part of the homework, and ask question if you don't manage to. Yeah, it was part of the exercise at the first place, but as we stretch time.
Yeah, we'll have to make it part of the homework. Thank you for asking that question. Okay, so for the read path. Now remember we had the mem table, and then eventually we flush data down to our SS tables. So in the read path, what's going to happen when you go to read something, it's going to go to the mem table first, right? See if your particular partitions are there, and then it will go to any SS tables. Now, data may be stored, and Cedric was just talking about this a moment ago, right? You could have data for one partition that's actually stored in many SS tables, depending on like if you had an initial insert and then later on you had an update or something to the same partition. So data, thanks, Cedric. Yeah, so data one partition could actually be stored across the mem table and multiple SS tables. So let's see what this looks like. So the mem table is actually pretty simple. Now, again, by the way, we're showing this to you just so you have an idea of what's going on. All the stuff is being done for you under the hood, right? So there's nothing here that you need to manually do. But let's say I have a request for some partition token 58 to come in. Then in the mem table, it'll actually just be able to go, if it has that in the mem table, it'll actually just be able to read that partition right out and send it back. Now, in the case of the SS table, imagine I have this immutable file with all these partitions in it, right? But it would not be very efficient if every time I went to read a partition out of an SS table, I had to scan through it to find, where a particular partition is. So what's happened is the SS table not only holds the partitions themselves, but it also has byte offsets for each one of those partitions. There's a mechanism called the partition index. And what this is essentially it's an index of those byte offsets. So if I have some request come for that partition token 58, it's going to go, okay, where's 58? I find it in the list and go, oh, it's at byte offset 7,192. It goes right to that spot in the SS table. It doesn't have to scan through the whole thing. It's all about reducing the amount of IO time, the amount of IO seek that I have to make the efficient as absolutely fast as possible. If you think about it, the slowest component we have is disk, right? Now, SSDs are actually quite fast these days, right? But if you imagine, especially spinning disk, right? That's going to be the slowest components. We want to make this part as absolutely efficient as possible. But over time, your SS tables, they get a lot of partitions. They grow really big, right? So even the partition index and such may not be enough. So there's another mechanism called the partition summary, which is essentially an index of the index. So the summary is in memory this time. And notice here what's happening is you'll see that, again, I'm looking for my partition token 58, but now it's going to cover a range. I'm going to go, okay, well, are you in token range 56 to 100? 58 fits in there. It'll give me the byte offset for whatever tokens are there, moves to my partition index, and now I go right to my byte offset. So it's another optimization that's in place to help reduce the amount of IO reads that I may need to get my data. And then finally, you have, actually, no, I have another one. Another piece that is called the key cache. Now imagine, this is also in memory. Imagine you have lots of reads that are going to the same partition over and over. That'll eventually bubble its way up into the key cache, right? And then if you notice here, it is storing the byte offset directly. It's essentially just kind of giving the direct address to where that data is on disk, right? So this is for data that is being read a lot. The key cache will eventually come into play, and then you'll essentially be able to read that position right out of memory, go right where you need to in disk. Again, this is all happening for you, again, automatically. And the last one here is the Bloom filter. I like to call the Bloom filter like it's the not there filter, meaning I could have a single partition that exists in many SS tables, but I don't want to have to look at the index and stuff for all of them. So the Bloom filter comes into play to say, is it not there, right? And it will be able to tell me definitively if it's not in a particular SS table and just skip it, right? So why go and read that if I don't need to? So it is another optimization that's in play to make reads even faster. So all of these things come together to try to make your reads as efficient as possible and reduce the amount of IO seeks and IO time that you have to make those fast. Cedric, anything else you want to add here?
No. You were sharp.
Great. All right, so so we are going to move into this uber high-level data modeling piece. It is really uber high-level. I saw a bunch of questions come in earlier regarding, what are key spaces? Like, how does that come into play? We're going to explain that now, right? This is where this comes into play. So in Cassandra, a key space not only contains all of your tables, but it's where you set replication. If you compare it to relational, it's equivalent to like a database or a schema, right? It's the place where you're going to hold all your tables. Within tables, you have rows and columns, just like you do in a relational database. That is not different at all. Logically, this looks very similar to what we'd expect from MySQL or Postgres or Oracle or whatever. The difference is in these partitions. So we've been talking about token ranges and stuff all day so far. These partitions, this is the key difference right here, right? The partitions are your base unit of access. This determines where your data is going to live on your various nodes, even in a single table. So let's look at a concrete example. I like concrete examples. So in this case, I have a user's key space. It's going to contain a table, in this case, users by city. Now, there's a convention we use here that when I define my table and then whatever my partition key is, I'm going to say by city. So I'm saying users partitioning by city. So in this case, I have two partitions, Phoenix and Seattle. So this would actually been my partition key. City is the partition key, and Phoenix and Seattle are each my partitions. And each of those partitions then are going to hold any of the relevant rows that use that particular partition. So you can see in both cases, actually, I happen to have 3 different rows that are in each of those partitions. Now, I mentioned clustering columns before, right? We can use them for ordering or uniqueness. Now, in this case, since I'm using them in last name and first name, again, it's alphanumeric since they're text fields. You'll notice that if you take a look at Phoenix there, you'll see that the last name is automatically ordered HLS, Helson, Lastfall, Smith. Same thing with Seattle. Like I said, so when it's being stored on disk, it's actually stored in this ordered format. Now, if I have more than one clustering column, they're going to order in the order of the clustering columns, how I define them. So I've defined last name first, then first name. So I'm going to order by last name, then I'm going to order by first name. Now, in this example, it doesn't actually have any last names that are repeated. But if you can imagine for a moment, if I had two Helsons and I had one that was Kevin and another one that was Andrew, Andrew would come first, right? So again, it will be stored this way on disk. Anything else that is not your partition key column or a clustering column will be data columns. Anything else is just your data. Now let's take a look though at how this actually looks when you have multiple partitions. So tables are going to hold multiple partitions. So if I have, again, a partition of Phoenix, partition of Seattle, partition of Charlotte, all those logically are going to look, if I did a select star from users by city, I would actually see all the data from Phoenix, Seattle, and Charlotte. However, each one of those individual partitions may actually be on different nodes in my database, right? So that's something to really understand. This key thing, if you can understand this one concept, you get to understand like, oh, this is what I mean by distributed, right? My partitions are distributed around my database. This is also why, for this quick example, it doesn't matter as much, but you'll hear us say that doing like a select star from everything is kind of an anti-pattern in Cassandra. And the reason why, if you're talking a small data set and you have like, a couple 100,000 things, it's not that big of a deal. But when you start, if you're using Cassandra, a lot of times you're in the big data realm, right? We're talking about gigabytes, petabytes, whatever, terabytes of data. And if you start growing to that size and I do a select star, I'm now selecting all those partitions that are around all those nodes as they're scanning all those nodes, right? So it's really important to understand that the data that is in your tables is actually, again, partitioned by these physical partitions that are actually being stored around your nodes. Cedric, I feel like you have something you want to say.
Yes, it's uber high level. We go more into the detail next week about partition and data modeling, but I got 10 times what is a good partition. Okay, so I will make it very quick. So we want to avoid too big partitions. So what is a partition too big? More than 100,000 records, more or number of records, or the volume more than 100 megabytes within a single partition. That's tends to be too big because now my partitions are replicated, it's taking times. And also on a single cell, we tend to insert data not bigger than 10 megabytes. But having partition with a single record, a unique identifier as the partition key, totally fine. As long as when you request data, you don't need to hit a lot of partitions. Select star from a table, you don't want to do that because you are doing a full scan of your cluster. But except from that, the partition key should be your where clause or your pseudo group by. But as we will dig more into the detail next week, I won't go this far.
Yeah, we'll get in a lot more detail about all the data modeling and stuff like that in the following week. Okay. Then the last thing is we're getting close here to wrapping up the material. Now, you didn't have to do this in Astra because this was done for you. But when you create, if you're using your own Cassandra database, you would create key spaces like this. Now, I mentioned that key spaces not only hold your tables, but they set your replication. So here I'm going to create key space users. That's going to be my users key space. But notice this with replication, right? So there's two things that I want to point out right here. The replication strategy, network topology strategy is the standard. This is what you should use. You'll find that when you create key spaces the first time, they use simple strategy. This is because we're kind of erring on the side of even like a single node, and just the basic setup to get going, right? Just know that if you're doing anything that is outside of like a quick database on your laptop or a test system or something like that, that you should be using network topology strategy. If you're not, and then you have multiple data centers, it's not going to work very well, right? So that's the standard. It starts with simple. You just change it if you are in a real production system. Notice that replication factor right there. That number sets the replication factor. That's it. If I change that number, my replication factor changes. Matter of fact, you see that data center 1, that's my data center. I could put a comma there, say data center 2, another 3, and I now am automatically replicating to 2 data centers, right? And it's automatic. Cassandra just does this for you. That part is automatically handled. I mean, that is super, super cool. You can also go back the other way. If you remove a data center, you alter this key space, you alter your replication strategy and your replication factor, and that's it. And you can just go either way, right? It's super powerful that it does all that replication for you out of this one thing. If you're creating a table, if you're doing this from the relational world, if you're used to this, it looks exactly the same. It's very, very similar. It's on purpose. Create table, my key space dot table, whatever fields, my column definitions, and then the primary key. Cedric, do you have something you want to add?
No, that's totally what we cover next week. So let's maybe
we'll just move past it. Yeah, we'll get into a lot more detail about all this, and then I'll go ahead and wrap it up because I know we're getting into the thing. So what we're gonna do today is, because we ended up taking more time than expected, we're gonna give the Working with CQL notebook as homework. We're going to add that as part of the homework. Honestly, it should take you like 10, 15 minutes. It's not that big.
It was part of the homework anyway. But yeah, now you have to do it on your own and import it the same way as we did with notebook number 2. Drag and drop.
Yes, that's right. You just drag and drop it right into your studio and you're good to go. You'll notice there's some bonus sections in there as well. Some of you were asking about like CQL, let's get in the language. This is going to start to do that. You're going to start to go through some of the basic commands of how do you do things in Cassandra using CQL. Here's what we're going to do. Here's homework. We're going to wrap this up.
Yeah.
So like we said, finish the notebooks if you're not done. So go ahead and do that next notebook. This form, these links, by the way, should be in the email that the follow-up you're going to get from Jack. We also posted all of this in the show notes of the YouTube video as well. They're also here in the slides. We try to put them everywhere so you guys can get to them. But please provide feedback to our team with the form here. If you haven't already, go create an account on Community and create an account at Academy. Again, it's all free. There's no paywall. There's none of that going on here. Community is, again, the way that we're going to answer long form questions. Not only that, it's a really great way to interact with other folks, not just DataStax folks that are in the community and have lots of experts that can help answer things. Academy is where all the coursework is, right? The link for DS201. So I recommend everyone to do this, but if you're really looking to take the exam eventually, you have to do this, right? You will not pass the exam if you do not go through DS201. So go through DS201. You can just watch the videos, take the quiz. Again, we'll provide the links around. And then this last part, this exercise of the week, this is that validation form that I was talking about before that just lets us know that you were able to get through the material and do some of the homework. And again, if you complete those throughout the whole series and you get them all right, we're going to have some really fun swag for you for the top 10. Or I'm sorry, there's no top in that one.
Yeah, we will randomize, I think.
Yeah, and we do provide the links for like where's Academy stuff. Again, you're going to get this in the materials we send you, and they're also in the GitHub repo and everything. I've kind of talked about all these pieces, and if you didn't see it, the last thing there is that the Cassandra Workshop series is the GitHub link. Again, you can always reach out to us in Discord, on LinkedIn, wherever, if you have any follow-up questions or anything. Again, there is the direct link. I've provided the link in multiple places for 201, but 201 is the one that you need to take for homework. And then finally, next week, we will be getting more into data modeling. We're going to, in the following, follow up with the application development stuff. And then in the final 4, we'll get into more of some of the admin performance testing, benchmarking, and then deploying with Kubernetes.
Yes.
And then with that, all right, 2:35.
Not bad, not bad. We wrap it up. So tomorrow we do the same stuff for Apache regions because it's late for us. I'm based in Paris. It's getting late. And next week's new topic. But even tomorrow I will be there answering questions. It won't be me on screen. But until then, see you next time.
Yeah, and thank you everybody for sticking with us for an extra half hour and going with us through those hiccups. We'll have that taken care of next week. Since most of us are authenticated with our Astro databases now, we shouldn't have that at all. So again, thank you very much for coming. We will see you next week. And thank you, Cedric, for co-hosting with me today.
Oh, that was fun.
All right, everybody.
Always a pleasure. Take care. Bye.